Neeraj sir, just check on YouTube whether it is streaming or not. Neeraj sir.
Yes. I'll check. Bouncer is working fine.
Okay. Yes, I think Dr. Pradeep has joined.
Yeah, good morning, sir.
Good morning, sir. Good morning, sir. Good morning. How are you, sir?
I'm fine, sir. I'm fine. How do you do, sir? Good going? What's up?
Sir, everything is good, sir. Your blessing.
Okay. Fine, sir.
Sir. Okay, Dr. Khan, are you there?
Yes, I am there.
Okay, good morning to all. Today's resource person is Dr. Pradeep Kumar. He has joined. So I request Dr. Sohail Ahmed Khan, Assistant Professor from the Department of Computer Science, to introduce Dr. Pradeep, sir. Please, sir.
Good morning to all. On behalf of Indira Gandhi National Tribal University, Amarkantak, I, Dr. Sohail Ahmed Khan, welcome all participants and our resource person in this workshop, Machine Learning and its Application, organized by Department of Computer Science. It's my pleasure to introduce our subject expert for this session. Welcome, Professor Pradeep, sir.
Thank you, sir. Good morning. बहुत shukriya.
Good morning, sir. Good morning. Shukriya, sir. Shukriya. So here a brief introduction about Professor Pradeep Kumar. Dr. Pradeep Kumar is a professor in Department of Computer Science and Information Technology at Maulana Azad National Urdu University, Hyderabad, a central university. He received his master's degree in computer technology and applications from Delhi Technology University, formerly Delhi College of Engineering, Delhi University. He completed his PhD from the University School of Information and Communication Technology, Guru Gobind Singh in Prastha University, Delhi. His research interests include software reliability engineering, model for software matrices, machine learning, neural network modeling, and soft computing. He has more than 50 publications in Journal of International Repute, including national journals, conferences, and proceedings of the international conferences. He is member of Association of Computing Machines, ACM India, member of Computer Science Teacher Association, USA, senior member of International Association of Engineers, member of International Association of Computer Science and Information Technology, Singapore, and senior member of Universal Association of Computer and Electronics Engineers. He is a member of editorial board for various national and international journals in the field of software engineering and program committee members, paper reviewers for several international conferences. We welcome you, sir, in this program. Hope our participants will get benefited from the expertise and experience of our experts.
Thank you, dear Suhail Ahmed Khan Sahab. बहुत shukriya. Jazakallah for the nice words you have introduced, you have expressed your ideas about me. I mean, audience will tell you the better what was the content you just have gone through and read out. But it's nevertheless, it is a great pleasure to be associated with such an event going to be conducted by one of the central university. And theme is on machine learning and its applications, 1 week international workshop on Indira Gandhi National Tribal University, Amarkantak, conducted by the Department of Computer Science. And before I start my presentation, I take this privilege to extend my best wishes and the congratulations to the convener, Professor Vikas Kumar Singh sir, and my dear coordinators, dear Pawan Singh and Dr. Neeraj Kumar Rathore. So it is indeed pleasure to join this workshop this morning, and I welcome you on behalf of the this workshop organizers to my all participants and the audience also. And with the just few words, I'd start my presentation because it is a second day of the workshop. So I will take from some basic concepts to the then implementation part. However, it may not be possible to simulate and demonstrate on Python, but I will try to touch upon that. And meanwhile, I request to all the dear participants, kindly do interact in between. No need to wait till the end of the session. Meanwhile, in between, if you have any queries, any concern, any question, kindly do raise it. It would be a then better interaction. So, Pawan sir, with your permission, I just share my presentation and let me know for any technical, flaw if there.
Okay, sir. Please go ahead, sir. Thank you.
Fine. Pawan sir, presentation is visible.
Yeah, it is visible, sir.
Okay,
It's quite visible.
Okay. So fine, very good morning to you. So this is a presentation on the machine learning algorithm. So I would like to try at least touch upon one supervised learning and one unsupervised learning algorithms. I'm taking two applications, broad application of machine learning, that is classification and prediction. And this is a brief outline of this one. We start with some basic slides, then the models and the techniques and the two applications I'm going to put forward and look forward to discuss with you, and followed by a summary and some few little bit references. So, yeah. This is a definition. I start from a very basic definition, and I request and rather than suggest to all the dear participants, try to understand the few just terminology, and that will take through you the entire session of this one. This is the definition given by the Tom mission. A computer program is said to learn from experience E. There are going to be altogether just three words. E is a word. Experience with respect to some task T. Task T is going to be the two tasks, classification and prediction. And then there's some performance measures P. How do we measure the performance of this one? So the definition says that for a computer program is said to learn from experience E with respect to some task T and some performance measure if its performance on task T improves with experience A. Now let us understand, please. There is just three words E, T, and the P. It's nothing, it is the experience we are calling here. Experience is nothing, it is your the past observations, past behavior. So machine is going to learn from the past behavior, from the based on the past observations, the historical data or the historical behavior, right? With respect to some task team. Task team is the we are going to perform broadly two tasks in machine learning. One is the classification and one is the prediction, right? The classification, later on we will discuss in much detail. Classification will be applied to the discrete kind of data, and prediction will be applied to the this continuous kind of data. And the performance would be measured in terms of the matrix. Matrix is the measurement criteria applied to any software product and the services. So the two matrices we will be applied over here. One is the error matrix and one is the confusion matrix, right? So the definition says that any program, any computer program will be able to learn based on this experience E if its performance P improves over the for this given task. Now, for example, take some examples over here. We wanted to measure a temperature of this room temperature for whatever purpose. Either we wanted to switch on the AC or we want to switch on the geyser, or let's say the heater, because the winter is going on. So T would be a task. So the task estimate the desired temperature of a room given in a given condition, either a north or in the south. Here we are in Hyderabad, so we would like to put on AC on, and you are if north of the this winter is going on, so you would like to switch on the heater. So you need to measure the temperature. So this is the task. So need to measure the temperature. E would be the learning from the temperature data set. Temperature data set is nothing. It would be part of the previous temperatures recorded of that particular room, particular building, particular organization, and in that particular season over the years of, let's say, 10 years, 5 years, 3 years. You have consistently and periodically or at a regular interval, you have measured the temperature of that particular room. So this becomes the E. E is nothing, that is, it is a past data or the past observations. And now the P, accuracy of the desired temperature. So based on given this temperature of the previous years of the past, maybe for few months, maybe for few weeks, maybe for few years, and if I am able to measure the temperature of this room accurately, then the machine would be able to learn. Else, if you are not able to, if the performance, let's say first we measure this one temperature, and this measurement should be as accurate as possible. It should not be like that. Let's say now right now temperature in Hyderabad, it is almost 20 or 21, and the machine is telling is 42 or 41, or let's say 23 or 20. So it should be as realistic as it could be. I mean, as accurate as possible. So this is one example of this one. You can take another example for based on the previous history or the past history. You want to measure or you want to predict the disease of a patient. Let's say you just want to identify whether a patient is suffering from a fever or from the let's say fever hai ya sugar hai ya some TB hai ya any other some cold cough whatever. Nowadays COVID is scaring everyone. So what the task would be a classification. Whether is suffering, means it would be a classification problem. Whether you are identified as a positive or you are identified as so sugar hai aapko hai ya nahi hai. Up to what level, that would be a later part. But initially, if you need to identify and diagnose whether you are suffering with the sugar or not, so it would be a classification problem. So T would be the task as a classify the patient as a having a sugar or not. Then the e-learning, what would be the experience or data set of the previous history? Previous history would be of the patients of the number of patients with the same group, with the same lifestyle, with the same conditions, same physical, logical, social. I mean, all those parameters, whatever can contribute to this one. And then P would be the accuracy, that how accurately we are going to classified or measure either a person who doesn't have any kind of disease, and even if you make a prediction that you have this and all, so that would be a critical cases in that. So this is just one example, and this one, and from these three words E, T and B, I take this presentation forwards, And I look, anyone, if you have any queries, please don't wait till the end of this one. So this is one. Now, so this slide shows that the difference between the typical machine learning and the traditional machine learning. So you see this is the about diagrams. It shows that this is simply data, programs, and there is the output. So there is the input, there is the output, and you are processing and you are writing some codes and execute it later on. But you see, in the case of machine learning, there is a data also, I mean, input is also here and output also, and the program is going to automate. So this input, it is going to be some sort of either a mapping problems in case of supervised learning, or it is going to be an unsupervised problem if it is getting some patterns, matching, sequencing, or some sort of relationship. So there's the input also and the output also, and this program is going to automate. And this computer is set to learn if this program improves the performance for this given input and associated output. So this is now how this program is going to work. So naturally, because it is automated, it is not going to be a manual phenomena, manual exercises. So this program need to be trained and testing. So how this program is going to be training? Naturally, there are going to be a symbolic word as a training, but it has to be written in terms of the instructions. Codes हमने उसके लिए लिखने पड़ेंगे. And then how it is going to be decided, defined. Either it would be rules, patterns, models, or whatever, right? So this would be a part of your the training. And in order to validate this model or these programs, we need to test and validate this program, or later on we will be calling as a model, right? So then we are going to use a new data or the unseen data and then measure the output. So for if unseen this given input or the unknown data, if we are able to get this output correctly, then this machine is going to learn perfectly all right. So this is the scenario it's going to elaborate over here. So the training, how we are going to provide the training, we will see in the further slides. So training and testing would be a part on this given on this data or the previous unseen data, or the we call it later on simply data set from any repository or you collect it, right? So, and we will making a prediction for the unknown data or unseen data. Now, because a lot of things are moving around data and the kind of data, right? And then converting, dividing into two forms: training, testing, validation, and all. So let us understand the kind of data we are going to deal with it from the exploratory data analysis point of view, because we need to apply so many statistical techniques. So let us understand how does it is going to help us before we apply or before we start the machine learning. And also for a given data set, can we understand that, can we come to know that which kind of machine learning algorithms we are going to apply? So that can be clearly understood by the given type of data itself. So let us go through this one. So broadly, we categorize this data again from the statistical analysis point of view, because we need to apply some statistical analysis. As you have seen, we need to measure the performance, we need to measure the, we need to apply this statistical analysis, prediction, regression, whatever. So this data is just from the statistical analysis point of view. So here broadly two categories are there. It could be your simple images, text, videos, audios, whatever, or it is a labeled data. Just try to understand the labeled data. Labeled data is nothing like that. Let's say if I categorize a gender, right? So gender could be categorized either a male or it could be a female. Of course, there could be a third category. So label is what? Male is a label and female a label. And there is no any specific, if I want to just further apply any some sort of statistics, and I just encode male with the 0 and female with the 1. And then later on I take simply the mean of these two values. So here it doesn't matter why you have taken male as 0 and why you have taken male as a female with 1. So there is no any specific order or the sequencing of this categorical data. And this simply called as a categorical data. So label, it would be, so under this come to the labels. So label, either there the label would be present, I mean for any input there is a associated label, present hoga ya absent hoga. To the left side, if you go with this deal with the images, text, audio, video, data, then the feature extraction, feature properties, attributes, and the dimensionality reduction, all these will be applied over here. If we are dealing with the label data which is present and absent. If the data is present, then it would be a supervised learning, right? If the labels are absent, then it would be unsupervised learning problem. That one we will also see how the, but I'm sure if you are able to understand here, if there is a for any given input, there are the associated output or the labels are there, then it would be a supervised learning problem. That any algorithms you are going to apply, either you start from the decision tree induction algorithm, naive Bayes, or the this artificial neural network, support vector machine, and any other this supervised learning. If it is absent, then it is going to be unsupervised learning, and then we will be applying all these either the clustering algorithms, median, mean, medians, or fuzzy clustering, or the DB scan, any hierarchical or partitioning algorithms we would be applying. Now further, so if we need to understand this further, whether this label or the data is a discrete or continuous. Discrete is a kind of data which is a time independent, and continuous is a time dependent data. So if it is a discrete data, then we are going to apply a classification. If it is a continuous data, we are going to apply a regression, or we use simply prediction. So what I was trying to explain in the previous slide. So at least you from the given data itself, you understand if it is a label data and label is a present. So then we will be applying or dealing with the supervised learning. So if the labels are the discrete, then it would be a classification problems, and the all classification algorithms can be applied to this one. If it is a numeric data or continuous data or time dependent data, then we will be dealing with the regression, or sometimes we call it as a prediction also, right? For example, take for the classification, digit classification. Altogether there are the 10 digits, 0 to 9, 0, 1, 2, 3, 4, 5, up to 9. There are the 10 digits. So these are the discrete value. 0 के बाद में 0 आएगा, या फिर 1 आएगा, या 2 आएगा, या 3 आएगा, like this one, right? So between 0 and 1, there is no other digits, right? So this is a discrete kind of data, continuous nahi hai. So then we will be applying a classification data. In case of regression, let's say house price prediction. House price prediction, take any example of real estate. A lot of flats, a lot of township are coming around you and in your city. And based on the previous 3 years or 5 years data, based on the location, based on the area, the amenities and all the facilities, you can predict the price of a house. That what would be the expected price of this house in the days to come, right? So this would be regression problem. So from this slide, what I try to convey you that, so before you get into the machine learning, you please try to understand what kind of data you are dealing with it. Because if you can analyze and apply some sort of pre-processing, we will see why the pre-processing is applied, then you can be sure that which algorithms I'm going to apply and why. This was the reason for this particular. Okay. Now coming to this one, sir, from where the question would become, then from where this data parts would be coming out. So then we need not to worry about this one, the data science, and then the data engineering, data modeling, and take just an example of the social media. We are overloading with the data, everyday data. Either you talk about the Facebook, WhatsApp, Twitter, LinkedIn, or any other Instagrams or any other media, apart from the standard repositories, banking data, election data, retail data, any other data. So we have huge unstructured and bulky heterogeneous and time volatile, all these data we have with us. So now we need to analyze, we need to utilize this data in order to extract some insights from this one. And this way, machine learning is going to help to get insights from this huge data which is available. Just have a look of this one slides taken a few years back. there is an exponential growth. If you measure as on today's date, the data could be entirely different because it is a quoted data from some slides. Like Google processes 24 petabytes of data per day. This is a bulky data. Now, question will come: what to do with this data? Can we get some insights? Can we get something useful? Can we get some data mining or useful, which can be utilized for making some decisions for the business purpose, providing some services or providing some products, or making the things better and easier. At least this should be the minimum purpose. Facebook, 10 million photos uploaded every year. If you just, during this lockdown period, this could have been, again, have been, multiplied, multifold. 10 million photos uploaded every year. Then the YouTube, 1 hour of video uploaded every second. This is a scenario all over the globe, all over the world. So then coming to this huge, bulky, unstructured data, unformatted data, right? This time variance data, how it can be utilized to get the insight. This is the bottom line from this slides I'm going to try. Twitter, 400 million tweets per day. It has been during the election days and during some special campaigning and during this, COVID situation, vaccination program, and other issues. This also might have gone the multi-folds. So this much of data again we have. I'm quoting this one that because we are not handy with the we have this lot potential data with us. Astronomy, if you go into the galaxy, satellite data in the hundreds of petabytes. And then apart from this one, there are some of the standard repositories. Standard repositories, if you take from the machine learning point of view, then the UCI machine learning repository is there, and you will get the thousands of data sets, including all the domains, classification, prediction, healthcare, clustering, agriculture, housing, pricing, social media, all these ones, right? So genome is another project. You can get the data where you need to analyze this DNA and the RNA sequences. Biosequence is this one. So the statistics says that the 2020, the digital Guinness already reached almost 50 zettabyte, 10 to the power 21 data. And by 2030, that's everything is going to get connected using the Internet of Things or the Internet of Everything, right? And then the machine, this repository, and in addition to that, lot of data you can get from this Kaggle. From you can get this lot many data and other repositories. So question comes that what we are going to deal with this data and how it could be utilized. So the initial versions were like that. You can go for the OLAP, online analytical processing, or data warehousing, basic operations with this data, searching, sorting, indexing, querying, like this one, or the knowledge discovery, data mining, or the web mining, text mining, whatever, using the statistical modeling and applying some intelligent algorithm. But here we are going to work for this data-driven parts, predictive analytics, and the deep learning. And this is going to be the part of our machine learning applications. So this was the background, having this data set. And many times I have discussed this particular slides, and I have taken this is one from one of my papers, and it will give you the entire view of this machine learning applications and the algorithms. So kindly try to understand from it. The diagram is top to left and top to bottom, left to right. This is the flow of this one. And you see this, we start from this. We start from the data repository. Data repository we already has discussed, as you can take from any standard organization. A standard repository like UCI machine learning repository is a repository containing almost 50,000 data sets, thousands of thousands for the this disease health predictions, social medias, and spam mail filtering, all this kind of data. This one, Kaggle is another platform. You can get the thousands data sets, including the codes from the Kaggle. GitSub is another option. You can get the thousands data sets and the open source codes for all these classification and the prediction problem. So data as such we have understood, and apart from that you can collect your own. Like during the COVID, lot many repository has been prepared, and maximum are available on the GitHub, Kaggle, and the other platforms. So having this data repository, the upper part goes to the data categorization, which we have seen in the previous two slides. So it is giving you the data. It is either let me. So it is either a multimedia data or the label data. If it is a multimedia, audio, video kind of data, then we are going to apply the pattern matching, recognition, or the using the clustering, deep learning, etc. If it is a label data, like we have seen, so label if it is present and if it either not present. So if it is present, then it is a supervised learning algorithms going to be used. If it is absent, then we are going to use the unsupervised. If it is a discrete, then it would be a classification problem. It is a continuous, it would be a regression problem. So this is the upper part to the categorization of the data. Now come to this one, because and then moving downwards. So here we need to, because this is going to be more or less data modeling problems. So we need to train and test these models, what we call as a machine learning model. So before that we train and test, this data is divided into the two parts. One is the training and one is the testing. So these are the three categories and the criteria. We can divide this data set into training and testing. First one is the splitting criteria. So if the data set is marginally enough, huge enough data we have, let's say thousands records or observations we have, then we apply splitting criteria, which is nothing. You can split into two parts, either 70% for training, 30% for the testing, or the 2/3 for training and 1/3 for the testing. One should understand that maximum data applied for the training purpose, because once the model is able to train perfectly, it can work for the unseen data. That's why we use less data for testing and maximum data for the training. So if we have the huge enough data, we apply the splitting 2/3. Usually there's no fix and the hard and fast rule. You can take 30/70, you can take 60/40, but preferably 2/3 and 1/3. So there's the maximum data for applied training and less data applied for the testing. And the best part for validation purpose, we need to use the data which is neither used for training and nor for the testing. This is this. Now, if it is not enough, we have not below 1,000 order, then the leave one out is the one method. Give one set of data you use for the testing and remaining you apply for the training. That is for a moderate kind of data size, in terms of size. If the data is very small, let's say just 100 orders, let's say 100 200 observations are there, so then this is the best methods we apply. K-fold cross validation. So K-fold cross validation is nothing. K equal to something. Let's say K equal to 10. हम कुछ ले लेते हैं. Let's say there is 100 data sets है हमारे पास. Data is one. Number of observations or data point is 100. So we divide it into the 10 folders, each of containing 10 data, 10 points. So what we do, one folder kept for the testing purpose, and remaining 9 folders are applied for the training, and then we reshuffle so that the another folder kept reserved for the testing, and remaining all 9 folders are applied for the training. So the purpose is that maximum utilization of data is applied to train these models, which we are calling it is a machine learning models. This part. So now how do we decide that which algorithms are going to be applied? I suppose if we are able to analyze this, the upper part and the left portion of this data, then we understand if it is a discrete data, there will be a classification problem. So all the classification algorithms would be applied. If it is a continuous data, then we are going to apply the prediction algorithm. If it is a labels are present, then it would be a supervised problem. If the data are not present, it would be unsupervised. And in between, if we have partial, either it would be a semi-supervised or semi-unsupervised. And the third category of machine learning would be a reinforcement learning, wherein we apply for the correct classification as some bonus points, and we apply or reward some points, and then give the penalty for the misclassification. That is a third category, like bagging and the boosting, like random forest and the gradient boosting algorithms and like this. So now, so it would be the first part when we go for this the machine learning models. First one with the feature selection. Feature selection is this one. You need to identify the dominant features. So what features are going to contribute maximum in order to get the better accuracy and the proper accuracy. So model selection, as we have discussed, from above these two categories, either supervised, unsupervised, or reinforced. That would be models. And then the model learning. How would be this model learning? We will take this training and testing, and then this approach is applied as a recursive approach, because if initially we are not able to get the results in the first instance or the first iteration, then we need to either optimize this error, like if it is the example of prediction, then the error or the classification error would be the minimum, accuracy should be the maximum, or error, if it cannot be reduced to the zero, at least it should be optimized almost near to zero. So this process goes the iteratively. So this feature selection, optimal feature selection, broad categories we applied either a filter methods or we apply a wrapper method. These are a part of the statistical. Based on that, we decide whether which features should be taken into consideration and which features should not be taken into consideration. Now, when we come to the training, the testing, this one. So training goes here. So if training part has been done successfully, then we move to the testing part. So for testing purpose, the model will come from above side and the data will come from left side. And this it is going to be now testing. So before we apply testing, so we need to identify, we need to define some objective, what we actually want to achieve. So there could be some basic objective like that. We want to achieve the maximum accuracy. We want to minimize the error. If error could not be minimized, at least it should be optimized, or any other objective we wanted to, right? So in order to test this model, we apply certain matrix, which is a part of the model evaluation. So as we said in the previous slide, which is a part of the P, performance. So how this performance is going to measure here? So this would be a part P. This will be a part of E, right? And this is that point of T, task, classification or the regression. Now, there are the two categories of the performance matrix. One is the quantitative, one is the qualitative. So the performance measure, if it is a error matrix, it is the quantitative matrix. If it is a discrete value, it is the here it is written. If it is applied to the categorical data, then it is going to be a qualitative matrix. If it is going to be a continuous data, it is going to be your quantitative matrix. So when it comes to the quantitative matrix, they are the errors like error. Error is nothing. It is the deviation from the standard outcomes. So like, or then some derivations of these errors like mean error, absolute mean error, sum of square errors, root mean square error, normal. You can ask later on sometimes why these many matrices are applied, why not a single one is sufficient. And then if we go for this categorical data, so we applied this confusion matrix like accuracy, recall, passage area under ROC curve, and something like this. So if this target which we applied over here, if it has been achieved, then the model would be validated. As it is go back, if they're not achieved, then we go back and then either change the model or change the features, or then change this training and testing components and blah blah. All these methods you can apply. In case if this objective of testing is achieved here, then we go for the model validation. So model validation is this one, because we have trained and test for this given data set only. Now we want to validate this model whether it will work for an unseen data, unseen or unknown. Unseen and unknown data is the data which neither has been applied for the training nor has been applied for testing. So this would be real validation. But practically, because when we don't get the real values or the validation value, so what we do from this given data set only. So this almost 70% is applied for the training, and this testing part is further divided into testing and the validation. That's a 15% for testing and another 15% for the validation. That is for the research purpose what we usually do. And if all this has been validated, then the model is accepted for the deployment. And then you deploy either in any healthcare system, either you apply in any disease prediction, any applying the forecast of the house price or measure the temperature and whatever like this. So these slides, through these slides, I try to summarize of the today's session. And now quickly go with some classification and prediction example in details. I hope any question, if you have, dear friends, please you can raise. So this all now I'll quickly escape few slides because much has been discussed. It is as simple as that. Under the supervised learning, there is a data, importing the data from the various repositories we already have discussed. Either you take from UCI machine learning, you take from Kaggle, you take from GitHub, you take openml.org or any standard. Or BSNL का data है, corporate का data है, banking का है, agriculture का, any data set you talk, you can take it. And then explore is the meaning of the exploratory data analysis, because this data could be noisy, redundant, not updated, right? So we need to apply these pre-processing techniques like removal of the noise, or preparing the data, like treatment of the missing values, null values, and the outliers, and all this one. So after preparing this, making this refined, then we apply these models, training the model and testing the models, right? So known data will be applied for training and unknown data will be applied for the testing, right? And here you measure the accuracy. So then you applied finally model आपका predicted responses. So the new value, new data is nothing, which is a data not being applied for the training and testing. This was just this. We can move further. So supervised classification algorithm called as a classification, and unsupervised are the clustering. Pattern is like a feature vector observation. Depending on the applications, we select the features. Like text documents में है हमारा stop words, keywords, special words. Video में होंगे तो क्या features हो सकती है? Colors है, color histograms है, image है, edges है, intensity values है, fingerprints है, loops, arc, disease, valleys. Audio है तो pitch, sound, track, all this kind of. So under this supervised, we have artificial neural network, decision trees, SVM, k-nearest, neighbors, neighbors, like this. So three components, elements of this machine learning we need to apply during the machine learning applications. One is the representation, how to represent knowledge. So maybe in the form of decision trees, set of rules, instances, graphical models, neural networks, support vector machine, all these applies for the supervised purpose. Evaluation, two broad categories, confusion matrix and the accuracy matrix we have seen in the above slides. And the optimization of the variables, parameters, or generalize the loss and the error function, which need to be minimized in case of the when we are going for the supervised learning algorithms. This is a categorization of algorithms. Again, if you see, two categories are defined here. It is supervised, it is unsupervised. So develop predictive model based on both input and output. So input and there is an associated output level. So that's why it is a supervised. Two approaches, classification and regression. Regression for the numeric value, classification for the discrete value. If it is a classification problem, you can apply support vector machine, you can apply discriminant analysis, you can apply naive-Bayes algorithm, you can apply nearest neighbor. If it is a numerical, then you can go for the linear regression or the Gaussian linear models or support vector regression, Gaussian process regression, ensemble methods, decision trees, and the neural networks. If the data are not present associated with this one, so the unsupervised algorithms, you will go for the clustering. K-means, K-mediate, fuzzy clustering mean, DB scans, or the hierarchical Gaussian mixtures, neural networks, hidden Markov models. Neural network models you will find in both the categories. So it can be applied for the, this is due to this massive massive computational capabilities of artificial neural networks could be applied for the supervised also and can be applied for the unsupervised. So now this is a design cycle. How do we go about it? So initially importing the data from the repositories or from any other way. Then the second part is the feature selection using any feature selection technique, and then the model selection, right? If there is a classification or the, supervised, unsupervised, or reinforced, and then the learning, training, and testing, and finally this is the evaluation. So learning system here, if I take one example, this data, D is nothing, it is a and data points and observation, D1, D2, D3, Dn. Model selection कैसे करेंगे? कोई भी, for example, if I take y equal to mx plus c or y equal to ax plus b, एक linear equation ले लेते हैं, line की एक simple equation. This is the right. So when the objective function क्या होगा? Because continue, y would be the dependent variable, x would be the independent variable, and b are the parameters. B is the constant, a is the parameters. Learning you करेंगे उसकी testing training. So this could be simply written as a super y equal to fx or f such that xy, x input, y आपका output. So xi, yi. So it is not a transposition or transformation. It is a mapping for a given xi. What would be the y, right? And this is the function going to be defined. So this is the output function. It is a prediction function. This is the input, right? I suppose you get. So now under this one. We get another value which is called the epsilon, or this is the error. It is not merely an assumption that this error would occur, because there could be the data could be or the noisy, it could be biased, there could be a variance, right? When you capture the data, that then and there itself the noise can be injected into this one. So this error is equal to noise square plus bias square plus the variance. Noise is an unavoidable error. For example, when you are capturing the data, there could be a faulty capture. I mean, when you take the image from a mobile phone, it depends on lot many things. Like आपका resolution क्या है, right? Focal length क्या है, distance क्या है, lighting क्या है, background क्या है, interference क्या है, right? Reflection, refraction, all these light properties. Then the bias, error due to the incorrect assumption. No model is perfect for all the kind of situation. Every model is based on some assumption that could be applied in a particular situation. It cannot be generalized. One model would be applied on all situations. When you move for the generalization, then the accuracy and this acceptance of the model becomes lower. And this is a variation due to the variance of training samples and training examples. Samples, observations, examples, instances, it's all set. It's all set. So ये this हो गया. I'll just quickly this one. This slides already has been covered. Classification of this, accuracy कैसे measure करते हैं उसका. Partition करते हैं data का 2/3, 1/3 वो हमने कर लिया. Cross validation and this leave one out model which is known as a bootstrapping methods. This one is the best methods we applied. We called as a K cross validation. We already discussed this one. This is the feature selection methods. Quickly go, or let us go in the details. So purpose is the dimensionality reduction, because if you say this figure of facial expression, we have the nose, we have the ears, we have the mouth, then the fingers, hands, all these one, age, height, weight, dimension. But the most dominant features could be the eyes, or the nose, on the thumb impression. So this gives you the unique impression. Even when you go for the registry and all, forget about the blockchain. So this gives you the unique identity. So this is a dominant feature or the significant feature. So out of a given features, we need to find out the best feature. So and the main purpose is a dimensionality reduction, because when you have the number of variables, you go with the most dominant, that will give you to the better and the accurate result. So the two categories, unsupervised and supervised. For the supervised, we apply either the intrinsic wrapper methods or the filter methods. So recursive feature elimination, or apply some statistics or the feature importance, anything. From this diagram, try to understand. So here, if the input variable is a numerical and output variable is a numerical, this is also numerical and this is also numerical. So you can apply any Pearson mathematical regression or the formula to decide whether it has to be used or not. If it is the input is numerical, output is categorical, you can apply any analysis of variance, MANOVA, multiple analysis of variance, or any other. If the input is categorical, output is a categorical, then you go with the chi-square mutual information. Or if the input is a categorical, output is a numerical, then you have ANOVA, Kendall, or any statistical method. So from the given type of data itself, you can understand you can come to know that which methods for feature selection you are. So this is just for the feature selection. Then you need to optimize these features. That which are the minimum features going to contribute maximum. Right, so the purpose remains same. If you say have the maximum number of variable initially, then the classifier performance decreases. It improves when the number of variables are less. So it is a dimensionality reduction problem. So the feature reduction, the number of training or examples required increases exponentially with the dimension. So I leave this one and just quickly come to at least one algorithm of decision tree induction algorithm. So which is a classifier, which is a binary classifier tree. It is a tree like which has a root node, then the left child and the right child, and the subsequently goes further. So it is a flowchart tree structure. Internal node denotes it as, I'll take one data set and then apply to this one. Take this one as very quickly. This is a training data set taken from a queen, and you will find out in any data mining or any books this one. So this is a data set. There are altogether 14 records. 1, 2, 3, 4, 5, 14 samples, observations or records, kuch bhi keh lijiyega aap inko. And these are the features: age, income, student, and credit rating, and the bias computer. And the data set describes that based on this given input variable, age, income, and student category hai ya nahi hai, and then the credit rating of their card, whether a person or a student buys a computer or not. So there are the two responses: no, yes, no, yes, no, yes. So this is the outcome variable. This, right, and all these are the input variables, right? So, and it is from this one we can conclude that it is going to be a classification problem. So here there should be no much confusion, sir. कैसे होगा? क्योंकि ये outcome है, ये every 1, 2, 3, 4 input, 1 output. This is a dependent variable. These all are the independent variables, right? And the response is the outcome is a yes, no, yes, no. This is a binary. So that's why the decision tree induction algorithm was the better solution for this one. So here we are going to apply this one. Now, problem is start when we are going to construct a tree. Tree is nothing like a greedy algorithms. So it is a top-down recursive, divide and conquer manner. So it starts from the top and moves downwards till the leaf nodes are getting, right? So tree is constructed in a top-down, recursive, and divide and conquer manner. At its start, all the training examples are at root. So initially अब इसका हमने tree बनाना है. तो जब tree बनेगा तो इनमें से कोई एक root node होगा, या तो age होगा, या income होगा, या फिर student होना चाहिए, या credit ratings होगा. So we cannot apply any sequential or the random methods. We need to identify that which gives you the better solution, better classification. So what we do, by default, we can start from the age and then let us see how the tree grows and then apply income as a root node. But that would be a time consuming. So what we do, we can apply some statistical measures like information gain or the entropy, and then find out which attribute has the maximum entropy or the information gain. That can be taken as a root node here. So here it is taken as a age as a root node, and the question mark says that how do we decide whether the age has to be, why can't we start from the student, why can't we from the credit rating? So this has the maximum information gain. I'll show this in the few slides, and it is the tree is constructed now this way: age less than equal to 30, then the student category no and yes, and then the no yes. This the graining yes or no, these are the leaf nodes, and which says where the computer has been bought or the buy or the purchase. So, and now for each leaf node like this one, there is an independent path. We can generate the rules. So rule 1, if the age is less than or equal to 30, the student category is no, the computer buy is equal to no. If the age is less than or equal to 30, student category yes, then the person buys the computer yes. And this is the third rule. If the age less than 30 and 40, everyone is purchasing or buying a computer. If age is greater than 40, credit limit rating is excellent, then no. If credit age is greater than 40, credit rating is fair, it purchases the computer. So then now you can find out 1, 2, 3, 4, 5. The 5 rules can be generated using this one, and using these rules, you can come to know whether for an unknown or unseen data set, this person is going to buy a computer or not. So the knowledge can be represented now in terms of the if then else. So independent rules यहाँ पे हमने generate कर लेंगे 1, 2, 3, 4, 5, and based on this analysis of these rules, right? Based on this analysis of these rules, we can find out the unknown sample or the validation. But if we grow this, have a large data and then generating a large number of rules, so then it becomes a complex problem. That is the problem with the decision tree induction. And more than that, the data has to be pruned also, pre-pruning and the post-pruning, because the unnecessary data has to be eliminated before we come to the this analysis part. So these one the and the overfitting in the classification. So the two approach we apply, the pre-pruning and the post-pre-pruning, just before the fully grown tree and after the tree has initially you remove the features and then apply the tree construction. So another approach I take here quickly, Bayesian classification. This is a better methods over this decision tree induction algorithm. And the best part of this one, it is based on a mathematical theorem, right? So the assumption is that attributes or the features कोई हम यहाँ पे attributes कह रहे हैं. These are conditionally independent, right? In the previous case, those are the dependent on each other. जैसे age हो गया, फिर उसका income है, फिर rating है, फिर by, right? You know, so that is a dependent feature. Here in this case, we consider all features are as independent. So X is the given data or the input, C is the conditional, and probability that the sample observation which belongs to a class of C is the classification, by or not, whatever. For example, quickly if time is there, this is the Bayesian theorems. It's applied, and I'll take quickly example of this data set. If you have the time, please go. Let's say we have this data set, right side. We have been given a data set, play tennis example, and estimating P, Xi of C. X is the sample. For a given sample or observation, we wanted to classify whether the tennis will play or the play will take place or not. And the data set is given in terms of like that. There is an outlook in terms of bright hai, sunny hai, overcast hai, rain ho raha hai, ya something shadow hai, cloudy hai, kuch bhi hai. And then the temperature, hot hai, mild hai, cool hai, and something like this. And then the humidity, very high or the high, normal, high, something like that. And the wind flow kar raha hai, true, false, true, false, true, false. So based on this one given inputs, and then there is a class. So it is also a classification problems. Class will take place means game will not be played. No means no, and P means present. Yeah, no means not play, and P means play. Right? So play, not play, like this one. So we need to identify. So how these methods could be applied? So there are also we have the 14 samples of the observations. So total altogether. Now we need to identify how many not playing, how many N are there, how many P are there. 2, 3, 4, 5. 5 are the no, and the remaining 9 are the P's. So probability of this P or the ratio at least. Probability हम बाद में calculate करेंगे. So the this ratio or the frequency of playing P is 9 out of 14, and the frequency of playing not playing game is a 5 of 14. So total chances or total observation are 14. यानी कि 14 में से 9 टाइम गेम प्ले हुआ है, 5 टाइम्स गेम प्ले नहीं हुआ है. एंड डिफरेंट के लिए हमने यहाँ पे फिर वो निकाल लिया है कि अब ये निकाल लेते हैं कि जहाँ पे आउटलुक आपका सनी है वहां पे नो कितनी बार आ रहा है. सो सनी के लिए 2/9 और कास्ट के लिए 4/9. ऐसे चेक कर लेते हैं. सनी के सामने हॉट, देन हाई और स्नो, फिर सनी. तो ऊपर के दोनों रिकॉर्ड्स में आपका नो है, राइट? सो दैट्स व्हाई द फर्स्ट फीचर इज द पी सनी कंडीशनल पी. प्ले होगा नहीं होगा, राइट? सो 2/9, इसलिए ओवरकास्ट प्लेइंग 4/9, रेन फॉर प्लेइंग 3/9. ये पी के लिए है. ये फिर सिमिलरली प्ले के लिए है. ये P play and for not play. So different हम ये यहाँ से from this given data sets we can conclude. Now let's say a unseen sample. Please try to understand what we were talking about the unseen sample. Unseen sample ये है कि for example we wanted to know that it is an unknown data कि weather is outlook is rainy, right? Temperature is hot, humidity is high, and windy is false. Now I want to know whether the play will take place or not. So using this Bayes theorem or Bayes theorem, what we can do, we just multiplied all these probabilities all together, right? For play के लिए rain, hot, high, false, सबके लिए इन ratios को multiply कर लेते हैं. And let's say whatever the result comes this one. Similarly, we do for the not playing के लिए. And the result comes 0.018286. Now, from these two given probabilities, from these given two values, whichever is high. So here you can see 0.018286. It is the higher value. So but it comes for the not playing. So the final this example or this sample or observation or a non-sample would be classified in the don't play or the class or this tennis play will not take place. So this is the best part of this, that mathematically, numerically, we can come to know this one. Only the problem with this Bayes theorem is that somehow if the probability of this conditional probability of any sample should not be equal to 0. Why? Because let's say, for example, if any one of these value rain playing के लिए, hot playing के लिए कोई भी value यदि 0 हो जाएगा तो this value also would be 0 because there is a multiplication. So any value, that's why it is a conditional probability, and conditional probability says that this event already has happened, that event already has occurred. So at least there is a chance of happening is minimum 1. It should not be 0. That's the meaning. So this is one, and this is the third algorithm. I think if time permits, we continue, or else we can take some your queries. I'll just go quickly with this one, artificial neural network. So the two flavors we work here. One is it is a massive parallel computational capability with the ANN. That's the best feature of the ANN. So ANN are capable of massive parallel computational capability. And the two versions of in two way we can apply these artificial neural networks. One is the feed forward and one is the back propagation. The signals are propagated from the left to right and then the back to the out input signal. So this is a typical diagram. So this is the input vectors. This is the weight assigned, and this is a summation of this one. Then we apply some activation function, tangent function, or the linear unit function, or rectify linear unit function, or sigmoid function. Many activation function we can apply, and the output we get over here. So for the given input, we are just mapping with the output. And meanwhile, what we can do? This is a weight matrix, right? Or the weight vector is a one-dimensional array. So if we can want to change the signal, physically we can't make any changes in the input, but mathematically what we can do, if we want to change the value of the input itself, so what we can do, we can assign some weights. Let's say 0, 1, W0, W1 and something. So if the value of this W0 equal to 0, then there is no input signal at all, because multiplied with the 0, it will come 0. If it is multiplied with the 1, then the signal remains as it is and the input remains intact. And if we assign any value between 0 and 1 to this weight, so then this x0, x1, up to xn, these are the initial data points of the observation, that will be changed. However, the drawback would be typically that, sir, what would be the physical interpretation of these signals when you multiply? There would be no physical interpretations, right? But mathematically we can do, and this way we can train these models and can minimize the error function or the loss function. This is what the beauty of this artificial neural network. I'm going in a bit fast mode, because time is coming up. So the n-dimensional input vector x is mapped into a variable y, and this become a problem simply y equal to fx, or f such that x to y, which we saw in the previous slide. So this become a simply supervised learning problems, right? So scalar input and this one. So I'll just come. So two third parts of this one, training and ultimate objective would be the training and testing. So obtain a set of weights that makes almost all the tuples in the training data classified correctly. So initially what we do, initialize weights with random values between 0 and 1, neither 0 nor 1. Because if you do that, the input remain would be same as it is. Then feed the input tuples into the network one by one. So we define the network architecture, which we call basically a multi-layer perceptron. एक input layer है, hidden layer है, output layer है, then the associated bias है, weights है, learning rates है. ये सारे काम जब हम इसको implement करते हैं, इधर आप MATLAB में use कर रहे हैं या Python में कर रहे हैं या कोई भी any other tool आप apply कर रहे हैं, we do all this one, right? And then for each unit, compute the NAT input to the unit as a linear combination. Then the compute the output value using the activation function, different activation function we are talking. Then compute the error and minimize this error, right? If you are not getting this error minimum, then update the weights and the bias. So this one. So these are some of the tools you can apply for this machine learning: Python, TensorFlow, Open Neural Network, Apache. I'm comfortable with the Python, and Python is the I think one of the most widely free open source tool है, आप इसको use कर सकते हैं. And then IBM, AI1, Proteus. I have not worked any one of them except Python. I wish time nahi hai, else I would have shown you one demonstration of any particular algorithms. So I hope I will share my PPTs with you. And this is the Python. It is a beauty of this one is embedded with the enriched with the number of libraries, inbuilt libraries, pandas and the Scrappy. Scrappy means for the web scripting purpose, and it is for the containing different functionalities like SciPy, all the mean for all the scientific calculations, then the NumPy, all for the numerical computations, then the matplotlib applied for the data visualization. Then the scikit-learn, this is the library which is having almost all these in supervised, unsupervised, and reinforced learning. Decision trees induction algorithm, neural networks, support vector machine, right? Naive-Bayes algorithms, random forest, clustering algorithms. Many algorithms are built into this one. And Seaborn is an advanced feature for the data visualization. So I think time is coming up. Else ये UCI का spam based data set मैंने यहाँ से लेके I wanted to show you some demonstration, but time is coming up. So I conclude. These are some of the references I have taken from this one. The diagram of which I was referring. This is taken from these papers, and these are some one conferences and one books, and some textbooks, journals, conferences, and the data set. Data set, and as far as machine learning is concerned, 3 points: UCI machine learning, writer's data set for text classification, and data set from the openml.org, and all the machine learning algorithm under Python. This is scikit-learn.org. It is already also available. So with these words, I come to the conclusion and close the slide, and expect few queries from your side. Over to you, Pawan sir.
Thank you very much, sir. Thank you for a very detailed and elaborative lecture. Participant, if you have any query, then ask to sir. You can unmute yourself and ask one by one.
Good morning, sir.
Good
Yes,
morning.
ma'am. Good morning.
Sir, I just wanted to know the sampling methods, the k-fold and leave one out sampling methods. If we start using k-fold method and if our data changes, can we use a different sampling method also, sir?
No. Actually, k-fold cross validation method is applied when you have madam moderate data set, but the minimum है आपके पास में. Let's say 100 orders का है. So, and we wanted to utilize this data maximum. So what we do then, we keep in the folders. So one folder reserved for the testing purpose and other remaining folders applied for the training part. But if you initially have taken from any large repository, जैसे UCI का हो गया, GitHub का है, Kaggle का है, right? So then it comes in the thousands. Let's say 50,000 records हैं, right? Yeah. So then you go for the sampling initial purpose की split कर लीजिएगा 2/3 1/3. This is the standard practice. But as I said, you will find in the different research paper there is no hard and fast rule. Somewhere you will find 2/3 plus 1/3. 60-40, 70-30, 80-20, you can do. And best part, you applied in the different ratio and then take the mean value. People do this way also. This is a research analysis. So, and if it is of 100 order or the small data, then you go with the k-fold cross validation. In between, if data is moderate मतलब ठीक ठाक है कि 2000 का है, 100, 500 है, something like that. Because if you apply the maximum training, the model would be able to produce you the better accuracy. This is the logic behind. Right, because training जितने ज्यादा होगा वो उतना ही अच्छा unknown value के लिए, unseen samples के लिए better perform करेगा. So this is the logic behind going for the training part.
Okay, sir. Thank you, sir.
Does it partially answers your query, ma'am, or not?
Yes, sir. Yes, sir. Sure. And can I ask another question, sir?
Sure, ma'am, because there is no other one to ask. So you take your own time, I'm sure. Please.
Sir, in the artificial neural network, the threshold value, how should we set the threshold value, sir?
Which threshold value?
Sorry, sir, I couldn't hear.
Which threshold value? Artificial neural network में हम input दे रहे हैं, तो किसको threshold value कह रहे हैं हम?
Sir, like when we multiply the input with the weights, and if it is less than the threshold.
Yeah. So weight की बात कर रहे हैं. So weight को ना neither you assign 0 nor assign 1. The simple reason to try to understand, because x0 into w0. x0 input है आपका first input है, w0 initial weight है. तो w को यदि हम 0 कर देंगे, 0 into whatever, it will come 0. So 0 का तो कोई significance नहीं है physical terminology में कि signal loss. That is the meaning कि हमने input ही नहीं दिया उसको. और यदि हम उसको 1 से multiply करते हैं, so x1 into 1, it will remain x1. So x1 was the input. So the input remains simple. Change हम क्यों करना चाह रहे हैं? We wanted to achieve the better accuracy. Loss function को minimize करना चाह रहे हैं. That's why we have in the neural network जो हमारी hidden layers हैं, उसमें हम कुछ changes कर रहे हैं. ना हम input में जाके change कर रहे हैं, ना output में. Because that is a mapping problem. Classification algorithm लगा रहे हैं. So input intact है, आउटपुट इंटैक्ट है, एंड इन बिटवीन हम उसको मैनिपुलेट कर रहे हैं. मैनिपुलेट एक अच्छा वर्ड नहीं रहेगा, बट कंप्यूट कर रहे हैं. कंप्यूट कैसे कर रहे हैं? हम उसको बायस लगा सकते हैं, इनिशियली वेट चेंज कर सकते हैं, लर्निंग रेट लगा सकते हैं, मोमेंटम चेंज कर सकते हैं, एक्टिवेशन फंक्शन चेंज कर सकते हैं, नंबर ऑफ नोड्स इंक्रीज डिक्रीज कर सकते हैं, epochs, iteration plus minus करेंगे, right? All these calculation we wanted to get the maximum accuracy. So this is the purpose with the artificial neural network. Back propagation में क्या करेंगे? The output which is we are getting through this training. So this output is fed back to the input signal itself. So let the model itself understand this much of error is coming, or over learning, or over rate is coming. So then this way model optimize. So this is the purpose of applying artificial neural network. Is that okay, ma'am?
Okay, sir. Thank you, sir.
Okay, ma'am. Good.
Any more queries?
Sir, shall I ask one question, sir?
Yeah, please.
Yes. So what sir has said, that's correct. Whether we can use when the DMart and all other organizations are giving the discount amounts through their artificial intelligence by default, is there this process can be applied for that cases, sir?
Even sir, DMart application के लिए?
DMart या any other retail stores, so they are giving the discount amount.
See sir, once we capture the data, then you go for any application. Banking के लिए से fraud detection के लिए करना है, या हमने credit card distribute करने हैं, और credit limit हमने decide करनी है. So you go, loan amount हमने decide करना है, किसको देना है, किसको नहीं देना है. So we will go. Even the election is coming, sir, over the state, across the country. You go. This is a numerical data and the lot many prediction. अभी survey शुरू हो जाएगा, तो survey से पहले लोग sampling करेंगे. Once this election process starts, and the prediction will come, and whichever would be the better, that will depend on the surveying, sampling, and the technique they apply. The manual to kuch karenge nahi sir. So this is what once you capture with the data, then go for any application, and this machine learning is going to help you out.
So even this can be applied credit card usage also, no, sir?
Yeah, sir. Many application credit, just a fraud detection ka hai. So based on the inputs only, then you decide, na. So just by looking, because we are not going to this any manual, but physical intervention nahi hai. Ki you see the face and I'll tell you the rule. तो वो तो आपको based on the input data. So you go with the analysis. That's why the statistics plays a vital role in all these machine learning. So statistics तो आप लगाएंगे and then go apply with the intelligent algorithm. And that will give you the approximate. आपको बिल्कुल accurately दे रहा है तो means your model is working perfectly all right. If you are nearby to this one, it has the further scope. So once you capture with the data, then your process starts with this one. So you can do, sir. You can apply. Not only, see this COVID situation. There's the professor from IIT Kanpur. They are making lot many good predictions. I mean, they have made a lot many ki peak value kab aayega, kab nahi aayega. Yeah, this one. So it's a part of data analysis with intelligent technique.
Yes. Okay. Thank you, Professor. Thank you.
Okay, sir. Okay, sir.
Sure. Morning, sir.
Very good morning, sir. Please.
Sir, can we make the prediction on behalf of the live data?
Why not, sir? In the sensor, जो the IoTs में जाएंगे, let's say we wanted to, एक smart agriculturing हम करना चाह रहे हैं. So, when we want to go for watering, when we want to apply the fertilizers, when the crop, all these kind of, the sensors can be deployed in the fields and then they will capture, and these are the intelligent sensors, and then they will, keep the data and the forward to other, making some pre-processing and will alarm you, will alert you. Now you need to go for water, you need to go for fertilizer. Now, I mean, all this one you can apply, and the medical is the best example, sir. If you want to patient monitor a patient and who is in a critical situation, so the doctors and nurses cannot be all the time be available. So this one, that can be, so the sensor will capture the data, it will feed to the models, model will decide whether it is running everything, heartbeat hai, critical hai. So at least it will give the alarm, and through this alarm we are making a notification that it needs immediate medication, injection, whatever kind of thing. So certainly, sir.
Okay, sir. Thank you, sir. Thank you, sir.
Okay, Nagaraj sir, shukriya.
Any more queries? Okay. Dr. Khan, are you there?
Yes, I'm there.
Okay. So I would like to invite Dr. Sohail Ahmed Khan to propose vote of thanks of Dr. Pradeep, sir. Dr. Khan.
Okay,
Thank
sir.
you, Chairman, sir. It was a nice lecture delivered by Professor Pradeep, sir. The lecture covers the machine learning algorithm classification and prediction. And this lecture, he defined machine learning with appropriate example, including tennis example, difference between traditional and machine learning, and provide data classification and discuss supervised and unsupervised learning workflows with various examples, machine learning models, and selection of appropriate model for classification and prediction. Lecture was discuss about the feature selection model, algorithm of decision tree inductions, extraction rules, Bayesian classification, ANN, machine learning tools, and also about the Python. So we hope all the participants will get benefited by this lecture. It was nicely covered, the most relevant topic and examples on machine learning, and it was full of knowledge and nicely presented. Thanks a lot, sir, giving your valuable time for this program. And of course, it's all about your knowledge and experience, as like there was a share that कभी बहती हुई पानी की तहरीरों को पढ़ लेना, हर एक दरिया हजारों साल का अफसाना होती है. तो यहाँ भी वही था कि ये एक नॉलेज जो है बच्चों को मिला, एक बहुत ही कम टाइम में बहुत सारी चीजें सीखने को मिला. ये बहुत ही अच्छा अपॉर्चुनिटी था हम लोग के लिए कि आप जुड़े हम लोग के साथ.
Thank you so much, Sohail Khan, Sohail Saab. Jazakallah for your nice words. I hope I don't deserve that much appreciation, but it will certainly boost up my morale and as a teacher. So it was indeed pleasure to me, and best platform provided by, and great thankful to my dear colleague. Recently we joined Dr. Pawan Singh, and since last few days we have been in a very very good interaction. So my all the best wishes goes to you and your entire team, and look forward to see you somewhere sometime.
Thank you, sir.
Thank you so very much.
Thank you for giving your valuable time, sir. Thank you.
बहुत shukriya. Thank you, sir.
Okay,
Thank you.
Okay, sir. Okay, thank you, sir. Okay, thank you.
I take your leave and quit the
Sir,
session.
please send your PPT, sir. Also.
Yeah, so Pawan sir,
Yeah.
just I'm sending with this one, and then you whatever you like with these
Yeah.
PPT, that your
Yeah.
prerogative. I
Yeah.
will share.
Okay.
I'll
Thank you,
share.
sir. Thank you.
Just now I will
Thank-
share.
Okay, sir. Thank you, sir.
Okay.
Dr. Bhosle, are you there? Nayan sir, are you there?
कौन सर मैं क्लोज कर रहा हूँ आ रहा हूँ डिपार्टमेंट
Yeah. Nayan sir, are you there?
Yes, sir.
Okay, let me check whether resource person can join or not. Okay. Good morning, Vidyarthi sir. I'm able to see you. How are you, sir? Kindly unmute yourself, sir. Vidyarthi sir, please unmute yourself.
Oh, yes. Namaskar.
Okay.
Namaskar.
Namaste. How are you, sir?
I'm good. Yes.
Everything fine in JNU?
Except too much of cold.
Okay.
Everything is fine.
Okay. So, Nayan sir. Dr. Nayan?
Yes, sir. I'm audible.
Okay. Now today's expert has been joined. So I request you
Sir,
kindly introduce Dr. Dev Prakash Vidyarthi sir. Please, over to you.
Thank you, sir. And welcome to DP Vidyarthi, sir. It is a great honor and privilege to introduce you. Dev Prakash Vidyarthi, sir, is a professor in थांबवायला. Extremely sorry. Professor Dev Prakash Vidyarthi, sir, in the sorry, am I audible, sir?
You are audible, Nayan sir. You are audible. Please go ahead.
Thank you. Sir is working as a professor in School of Computer Science and System Sciences, Jawaharlal Nehru University, New Delhi, India. He has published more than 120 research papers in various international journals and transactions, including IEEE, Elsewhere, Spinger, Wiley, World Scientific, etc., and around 50 research papers in proceedings of various peer-reviewed conferences in India and abroad. And he holds many professional membership as like a senior member of IEEE, ACM, International Society of Research in Science and Technology, USA, as well as IACSIT and IAENG. And his research interests include parallel and distribution system, grid and cloud computing, mobile computing, Internet of Things, and evolutionary computing. With this brief biography, I request to Professor Dev Prakash Vidyarthi, sir, to deliver his session. Over to you, sir.
Yes.
Thank you.
Thank you, Dr. Narayan, right? And thank you, Dr. Pawan, also for giving me invitation to speak on some research work that we do here in our research laboratory along with my PhD students. So I would like to speak upon one of the aspect of the machine learning that we do have applied for our problem. So this particular workshop is on machine learning itself and its applications also. So as you know, and you might have gone through some of the lectures in a day or two, where you might have been given a notion that what is machine learning and how machine learning is applied, or how the machine learning is being applied in various fields. So I will not deliberate upon that. I will just like to talk upon how we do have applied the machine learning, right? How we do have applied the machine learning in our field. Okay, so let me continue. Let me start with our talk. Let me start our talk with by sharing the screen. So, screen. Are you able to visualize the screen?
Yes, sir. Yes, sir. You are quite visible, sir.
Okay, okay. So let me share the full screen. Are you able to see the full screen?
Yes, sir. Yes, sir. Please go ahead.
And it's moving also, right?
Yes, sir. Yes, sir.
Then it's okay. So as I told you, this is a problem which we do have, developed a model for this particular one, applying the machine learning approach of the problem of the resource provisioning in fog integrated cloud. So the resource provisioning means how to manage the resources. You can say it's a kind of a resource management. It's a kind of a resource scheduling. All these aspects are included in the resource provisioning. So we do have applied the machine learning technique for determining what kind of jobs or what kind of applications are coming for the data processing in fog integrated cloud environment, and how machine learning aspect has been applied over this particular problem. So this will be the problem that we do have to deliberate. Actually, this particular paper has been published very recently in Concurrency and Computation Journal of the Wiley, and exactly the DOI for this particular paper is given here. Those who are interested, maybe at the end of the talk, probably they can download, and if they are not able to download, he or she they can ask me for this particular paper. I'll be happy to give this particular document to manuscript to them. You see that what the title of the paper is, Intelligent Admission Control Manager, and why the reason we called it as intelligent, because of the machine learning approach that we have applied. So it is nothing but the machine learning approach for admission control, and we do have developed an admission control manager applying the hybrid machine learning approach. So why it is hybrid, the things will be clear to you in the due course. Basically, normally I divide this particular talk in two parts. One in deliberating what is fog integrated cloud, what we call as the fog integrated cloud, and what are the problems that fog handles, what are the problems that cloud handles. And in between, you do have the edge also. So edge computing, fog computing, and cloud computing all together. So this kind of environment. IoT also I would like to discuss, because factually the applications or the data are coming from the IoTs. So what an IoT is, I will briefly deliberate upon that. And normally I talk about the machine learning also, but here I would like to skip because the time is not given. Too much of the time is not given. It's just 1 hour talk. So I'd like to skip the machine learning aspect. And I assume that you already have gone through many machine learning techniques. So you are already aware of the machine learning technique. So this will be the part one, and in the second part, I will be actually dealing with the model that we do have proposed. That is the Intelligent Admission Control Manager, right? Coming to the part one of this particular talk, in which I will be talking about the fog integrated cloud and the Internet of Things. So starting with the Internet of Things, as what for we have created, or what for we are creating the environment of the fog integrated cloud, where from we are getting the data, it is factually mostly from the Internet of Things, right? It is mostly from the Internet of Things. So let us see what Internet of Things is, and why a huge amount of data is being generated by the IoT, and it requires the processing from a backend environment, which we do call it as the fog integrated cloud environment. So let us deliberate upon what Internet of Things is. Briefly, I would say that the Internet of Things are not only the Internet of the computers or computing devices, rather it is Internet of anything, right? Internet of anything. And some, you see that some used to call it Internet of everything also. Not just IoT, they call it IoE, that is the Internet of everything. But a general popular definition or popular terminology is IoT, that is the Internet of Things. And as this particular figure suggests, that Internet of Things actually considers that anything, that any physical objects that we perceive, that we can see, factually is on the internet, right? So if you look at this particular picture, the frying pan is on the internet, electric bulb is on the internet, refrigerator is on the internet, electric kettle is on it. So this way you'll find the automobile is on the internet, and many of the devices, many of the physical devices is on the internet. And actually what for these devices are, they are generating the data, and data requires processing. Based on the processing of the data, some action is to be performed, right? And that is why to process the data for these kind of applications, for these kind of IoT applications, we require a backend support, and the backend support is in form of the fog or the cloud computing, right? Or fog and the cloud computing, right? So you see that many of the devices, and they are constantly generating the data. They are giving the data through the internet, passing it to some backend server where the data processing takes place, right? Right? So this particular term, the Internet of Things, as far as the definition goes, it was coined by a scientist known as the Kevin Aston. So Kevin Aston is the person who coined this particular term, who is located in MIT, and coined the term of the IoT. Cisco contributed a lot in the IoT, and supposed to be, and it assumes that this particular term is born somewhere between 2008 and 2009. So it's almost 10 to 12 years back. This term was coined. The term IoT was coined. As far as the what IoT is, the proper definition of the IoT says that it's a network of physical objects. It's the network of physical objects, and you might have seen here all these objects that are connected here. Though it is a limited number of objects, all the objects that have been connected here, they are actually the physical objects, right? They are the physical objects that has been connected with the internet. And in order to connect these devices on the internet, physical objects, that we say that they are devices, vehicles, buildings also. So not only here the building is not shown, but building is also on the internet, and other items embedded with electronics. So that is what I said, that in order to connect it to the devices, these devices on the internet, these devices are to be embedded with the electronics, with the software, with the sensors, and the network connectivity. So what we require here, that these devices should house the electronic, because otherwise they cannot have the IP addresses, and if they cannot have the IP addresses, they cannot be connected on the internet, right? So in order to connect these devices on the internet, they should be equipped with these, that is the electronics, softwares, sensors, and network connectivity that enables these objects to collect and exchange the data, right? That enables these objects to that is the main purpose of keeping these physical devices on the internet. That is, they collect and exchange the data. And what for? They collect and exchange the data for making the things smarter, for making the environment smarter. So whatever the smart concept comes at the back of that, factually these kind of a data processing is involved, right? These type of data processing, whether you call it is a smart intelligent controller of this intelligent transportation system, smart city, smart healthcare, smart agriculture, all these terms have been actually equipped with our adjective which has been associated are the smart. And in order to make these environment smarter, actually they are to be on the internet, so that the generated data can be processed at the back end, and some useful action can be taken thereupon, right? There are certain more definitions of the IoTs, which says that, say, IoT, internet technology connecting devices, machines, and tools to the internet using the wireless technology. So over 10 millions of the things have been connected so far on the internet. Actually, this number is a misnomer. Now around 18 billion devices, right? 18 billion devices are already on the internet, which is supposed to further increase in the days to come, right? Again, we'll say that's a unification of technologies, which we discussed, that what are the devices that are having the kind of capabilities. So in order to handle those, many of the disciplines are contributing as far as the IoT is concerned, like low power embedded systems, cloud computing, big data. So cloud computing, as we discussed, to process the data. Big data is the technology that actually works upon the data, the big data. These are the technologies which will be applied on the big data, and eventually the data processing will take place at the cloud. So cloud, big data, machine learning heavily is being applied now over the IoT devices and the networking, because unless we are able to connect to the network, we cannot access the backend servers, and the data processing cannot take place. Right. So these are the techniques, or these are the technologies, and you can say these are the basically the core papers, core disciplines that are helping in making the IoTs useful, right? In making the IoT possible, rather. Now, a similar term is the fog computing, and the fog I mean, to process the data on the back end, we do require the fog computing, and fog computing is same as the cloud computing, with the difference that the computing comes closer to the data generating point, data generating devices, right? We already, I think we all are aware about the cloud computing, and as many of the organizations are now shifting over the cloud for their data processing. So cloud computing actually provides a backend environment, backend kind of a system, backend servers where the data can be processed. And not only the data processing, even the storage also takes place, right? But the cloud is little farther, where some data centers have been established, and many of the servers are lying there with the use with many of the properties that have been associated with the cloud for the data processing. But fog computing is almost similar to the cloud computing, but then computing comes closer to the data generating devices, right? As far as the definition from the Open Fog Consortium is concerned, they define the fog computing as it is a horizontal system level architecture that distributes computing, storage, control, and networking functions. So you see that up to this particular networking functions, the definition of the cloud and fog computing is same. That is, whatever cloud does, fog also does the same. It's a horizontal system level architecture, which is cloud also, that distributes computing. Cloud also does the same, distributes computing, and computing, storage, control, and networking functions. But now here the difference lies between the cloud and fog is that these all functions are closer to the users. Cloud is not closer to the user, but fog is closer to the user. So closer to the users along a cloud to thing continuum. Along a cloud to thing continuum means that whatever cloud does, fog also does. Cloud and fog, they all go together in association, so that they complement each other. It is not that once the fog computing discipline came, the cloud will vanish. Cloud will also be there, fog will also be there, because the fog is limited in capacity. Fog is not as powerful as the cloud computing is. Fog cannot process all kind of application, all kind of data, and for those probably we need to rely on the cloud computing ultimately. Just I'll take a little because there is some call for me, so I'm just attending that call. I'll come back very soon. Yeah, I'm sorry, I'm just coming back. So, are you able to see?
Yes, sir. Yes, sir.
So just going with the definition of the cloud. So what it says is that all sorts of computing which has been provided by the cloud, now it has been brought closer to the user in terms of the fog computing. As the name itself says, the fog is usually close to the earth, that is the user, and cloud is little farther, and the same kind of a notion has been derived here in defining these terms as the fog computing and the cloud computing, right? You see that fog fog alone is not possible, and that is why it is written along a cloud to thing continuum. That is, it's a something like the cache memory and the main memory kind of a concept. That is, you do have the main memory, but when you introduce the cache memory, it becomes faster because the cache is closer to the processor. Cache is closer to the machine. Cache is closer to the so it becomes faster. But then alone cache memory will not work. So along with the cache memory, you definitely require the main memory. Similar kind of a concept has been taken or has been derived in the definition of the fog computing and the cloud computing. So an extension of the traditional cloud-based computing model, where implementation of the architecture can reside in multiple layers. So what kind of layers are there in the fog and cloud? That will be discussing along with the that will be discussing with the help of a figure as well, right? Let me make it a full screen. Similar kind of a concept is the edge computing. So edge computing, and you will find that in literature, many of these literature, they will say that the edge and fog computing is one and same. But when you do have to work on the this particular work in this particular area, then you have to differentiate between the edge computing and the cloud computing. So what an edge computing is? Edge is actually the computing being performed at the device level itself, at the data at the device which is generating the data. So you will find, and you might have seen in the IoT, many of the devices that are connected, they are capable enough to process the data as well. They are having some small sort of a processor, so they have the processing capability. Not necessarily all the devices, some of the devices. So then we say that these devices are capable enough to process the data. So then if the data processing can be done at the edge itself, edge means that is at the data generating device itself, then we call this kind of a computing as the edge computing. So the edge computing and the fog computing will differ a bit, though both are doing the data processing at the data generation point itself. What exactly the difference? That quickly I will be going through it. So it doesn't mean the cloud will disappear. That is what I explained you. Some of the benefits that we can explain are that we can obtain from that we can perceive for the cloud and fog computing, or for fog and edge computing, is the latency. Latency means the data, as the data is not being forwarded to the cloud, all the internet hitches will be gone, and then the time taken to process the data will be faster enough. That is, will be getting the benefit in the latency. Latency is nothing but the time taken. Latency is nothing but the time involved in sending the data and getting the result back. So that latency kind of a thing will almost disappear when we are processing the data over the edge and the fog devices. Then another benefit that we can perceive is the privacy and security, because the data is not being floated on the internet. So all the breaches of the internet which is possible with respect to the privacy and the security aspect, that also will be gone. So another benefit that we can obtain from the edge and the fog computing is the privacy and security. Then third is the bandwidth, because the data is not being floated on the internet. So obviously the bandwidth requirement will decrease. Not necessarily all the applications are to be processed at the cloud. So the bandwidth requirement will decrease, and this will add to the benefit of the edge and the cloud computing, right? Now, if you look at this picture, probably the edge, cloud, and the fog will become clear to you. So this is a kind of a pyramid which has been shown, and this is the architecture, the layered architecture of the fog integrated cloud. So you see that at the bottom of this particular pyramid, you have the devices that are actually constituting the IoTs. That are like you have the table lamp, you have the water tap, you have the electric pole. Similarly, many other devices, the refrigerator, your smartphone, such kind of a devices, many devices that are there on the internet. And as I told you, some of these devices are housing the processor also. They are keeping the processor. So if these processors can be utilized for processing the data, so let's say the data is being generated and is being processed at this particular level itself, then this constitutes the edge computing. This becomes the edge computing, because the computing is being done at the edge itself. Okay, so this is one where you do have the billions of devices. We already deliberated upon around 18 to 19 billion of devices have already been added in the IoTs. So here you do have the billions of devices. Now you go a level above when you reach to the cloud through the internet. So in between, the intermediate nodes or the intermediate devices comes into picture, and in form of the base stations, in form of the switches, in form of the routers, etc., etc. So nowadays you see that the routers are also equipped with the processors. The base stations are having the powerful processor, though the job of the base station or the router or the switches is to forward the data, forward the packets, not to process the data. They don't look at the data, they don't process the data, they just forward the data. But then ultimately it has been said, it has been decided that if these devices are equipped with the processor, they are already having the processor, why don't we process some of the data here itself rather than sending the data to the cloud? This has constituted in a new discipline of the fog computing. So you see that at the next level of the pyramid is the fog devices in form of the devices which I already deliberated, bridges, routers, base stations, and so many things that constitute or that contributes to the data forwarding rather than data processing. If these devices can be utilized, as I told you, then this constitutes the fog computing. And I am pretty sure that now you can differentiate between the fog computing and the edge computing, right? These are millions in numbers, not as many as the IoT devices. These are millions in the numbers. And then a level above, you have the cloud data centers where you do have the powerful servers as well as the bulk storage also. So whatever cannot be processed here cannot be processed here, then ultimately it will definitely be processed at the cloud data center. And as you know, that 1,000 of cloud data centers are there that are having the huge storage and the huge servers. The bulk servers also are there. So ultimately they are powerful. They are less in numbers but powerful, right? They are less in numbers but they are powerful devices. And anything which you could not process at these two layers, they will definitely be processed at the cloud layer. They will definitely be processed at the top layer. So this is all together constitute the fog integrated cloud. Right. This all constitute the fog. So what we do have perceived in our problem as the fog integrated cloud is this particular aspect. What we do have considered is this particular aspect of the fog integrated cloud. So this whole architecture, we are calling it as the fog integrated cloud. So there is a fog, and actually we are considering the edge devices also in the fog. So we do have named it as the fog devices. We have named it the aggregated fog devices, and then we are calling it the cloud devices. So all these three types of devices are there. These three layered architecture we do have considered in our problem where we do have applied the machine learning. I'm just coming to that particular part very quickly, right? Another picture that can differentiate very well about the fog IoT and these, you see that here we are calling it the IoT layer. So IoT layer is nothing but the edge. These are factually the IoT devices. These are the IoT. IoT means all the things that we can consider, that we can keep on the internet, that can be equipped with the minimum support, hardware and software support, and then these devices can be kept on the internet. So these are the IoT layer. Some call it as the edge layer. These are factually the IoT devices. So at the other end of the network, we have the edge. At the other end of the network, we have the IoT devices, and they constitute the IoT layer. A level above, we do have the fog layer. So fog layer means all these devices, the switches, and as I already deliberated. So a level above is the fog layer. And then at the top, you have the cloud layer, where you do have the various servers, powerful servers that can process the data very well, right? So this is all together that we do have considered in our model. Now, as I told you that normally I tell something about the machine learning aspect also, but I'm skipping this particular part here because of the timings that have been given to me, and I'm pretty sure that you are aware of the machine learning. But just introducing you what a machine learning is, that it is a computer program which learns from the experience E. Right? It's a computer program which learns from the experience E. So unless the program is able to learn, so normally we write a program in which we give the input and get the output. But the machine learning program is not just to produce the output. Rather, first it has to learn. Based on the learning, it will produce the output, right? So eventually the program will evolve itself. Program will, by the experience, it will learn, and then it will evolve itself. Ultimately, why for we are making the program to learn, so that it can perform well. It can perform well for some particular type of task, for some particular type of application. With the experience, the program has learned and it is performing well. So three parameters which is important in defining the machine learning is that the program is set to learn from the experience E with respect to some class of task T and performance measure P. So P is the performance measure which we use and experience, or which we use and see that now the program is performing much better, machine is performing much better with respect to the performance parameter P, right? So this is how we define the machine learning. And this was the definition, which is a perfect definition given by the Tom Mitchell for the machine learning. It's a branch of artificial intelligence, and as intelligence requires knowledge, it is necessary for the computers to acquire knowledge. So you see that now the computer will not be a straightforward plain computer in which you write a program, give some input, and produce the output. Not for that. Rather, we write a program and then we make the program to improve itself by making it learn, so that the program can learn, and learning is by the experience, by the data. The data is historical data, the past data. So using the past data, we make the computer to learn, and thereafter, once it has learned properly, we use that particular program. We use that particular program in, let's say, predicting what can be the output or what will be the output. This is what the machine learning is. Exactly what we mean by the machine learning is that the machine, that is the computer, it learns from the experience, from the past data. It learns, and then once it has learned properly, we are pretty sure, we assume that now the computer will perform well. Okay, so this is what exactly the machine learning is. If you look at these two pictures, probably you can make the difference between the traditional programming and the machine learning. In traditional programming, you have the data, you have the program, give it to the computer. So program execute on the computer using the input data and produces the output. But in the machine learning, you don't have just the data and program giving it to the computer. You give the output also. Output means the past data, right? Output means the past data, which even this computer or this program might have generated. So now you feedback the data, let's say, feedback the data to the computer, and then using this data, this program learns, and ultimately a new program, which is now, I'll say, an experienced program has been generated, an evolved program has been generated, right? So this is about the machine learning. Coming to what type of machine learning algorithms are popular nowadays: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. I'm pretty sure that you are aware about these learning mechanism. Supervised learning, where the data is labeled data. I mean, the past data, which we said, historical data, they are factually the labeled data. So we are using the labeled data to train the machine. Hello. Are you able to hear me? Are you able to hear me?
Yeah. Yes, sir.
So there is some disturbance in between. So I thought that, is it from my side?
Yes, sir.
There is some disturbance in between.
Okay,
Yes.
okay. Now it is okay.
Yeah. So I said that supervised learning is basically based on the data, labeled data. That is, the data labeling has been done in the supervised learning. And normally we use the classification and regression. Classification, where the data is discrete data. Regression, where the data is real values data. So based on this, we do perform the classification and regression. And based on the label of the data, we call this particular mechanism as the supervised learning. Unsupervised learning, where the data has not been labeled. So if the data is not labeled, we cannot perform the classification or the regression. Rather, we perform the clustering based on the similarity of the data. So here in the unsupervised learning, the data is clustered, and the clustering is based upon some parameters that can make the data similar. So we say that some sort of a similarity measures are used in clustering of the data, and this kind of a learning is known as the unsupervised learning. In between, we do have the semi-supervised learning, where some of the data is labeled data, rest of the data is non-labeled, unlabeled data. So we do perform the supervised learning on the labeled data, less in numbers, and then thereafter we apply the unlabeled data in testing purpose. So that particular aspect is known as the semi-supervised learning. And reinforcement learning is a bit different from all these three learning techniques, where the learning is based on the rewards. Learning will be based on the rewards. That is, normally randomly we do perform some action, and if action is good, the environment or the agent will be rewarded. or the environment will reward the agent. So based on the reward, the agent will assume that now it is moving in right direction. So this is the kind of a learning which is performed in the reinforcement learning. So these four machine learning algorithms are popular, and they have been deliberated a lot in the literature for various kinds of applications. They have been applied. I'm not deliberating much upon these kind of learning techniques. Rather, probably I can directly move to the my problem. Just giving you a picture, you see that the label training data is there. You do apply the supervised learning. Once this particular model learns, you have generated a model which now can predict, because it has learned, so prediction can be done by this. For testing, we use the test data, apply it on the prediction model, and then do some sort of a prediction. And if the prediction is accurate, probably we can say that the model is perfect. So this is what is done in the supervised learning. In some standard supervised learning algorithms are the nav-based decision tree, k-nearest neighbor, linear regression, logistic regression, support vector machine. These are some of the standard supervised. There are many algorithms for the supervised learning, but these are some of the algorithms probably you might be aware of. Maybe with one or two, may not be with all, but these are the standard supervised algorithm. Probably you can deliberate upon and you can look into, where in fact we do also have applied all these kind of algorithm in our problem. uh, uh, Moving on, unsupervised I already explained you just look at this particular picture for the unsupervised. So here the data has not been labeled, rather this is unlabeled data, and then based on the kind of a pattern, based on the similarity, like here you see it's a spherical, it's a circular object, it's a elliptical object, it's a triangular object. So depending upon the similarities between the data items, you can just consider these to be the data items. Based on the similarity, they are grouped together, they are clustered together. This kind of a learning is known as the unsupervised learning. Some standard unsupervised algorithms are the k-means, PCA, principal component analysis, self-organizing map, a priori algorithm, DB scan. All these algorithms are for the unsupervised learning. Then similarly, there are semi-supervised learning also, as I explained you, and I'm quickly moving all these things. This is about the reinforcement learning. So as I told you, there is an agent which we are making to learn, and this is the environment. So it's a puppy, it's a trainer is training the dog, and training based upon how the dog perform, how the puppy performs, it is being rewarded. So this is how exactly happens in the reinforcement learning. Just skipping all these parts and moving to the second part of our talk, which is the model, which has been proposed as the intelligent admission control manager. So let us see what we did here. So we proposed an intelligent admission control manager that is placing the jobs, where to place the job, on the edge node, on the fog node, on the cloud node, right? On the edge, fog, and the cloud node. We are calling it as the fog, aggregated fog, and the cloud node. So placing the jobs based on the parameters such as their CPU requirement, their memory requirement, their storage requirement. And besides, two more parameters are being considered, that is the priority of the job and the time sensitivity of the request. So you see that we already have explained you that we do have introduced the edge and the fog devices, so that we don't send all the applications to be processed at the cloud node. Rather, some of the applications can be processed at the fog node, at the aggregated fog node, depending upon their requirement. And thus, this particular requirement we are computing using these two parameters, the priority parameters and the time sensitivity. How much time sensitive the request is, how much time sensitive the application is. For example, let's say if we are working in the health IoTs, and we do have equipped, or we have attached some of the health sensors with an elderly person who goes on walk, right? So then you see that some of the data is being generated by these elderly person through the sensors that we have attached. Now the data processing requires this kind of application becomes a time sensitive application, because we cannot send this for the processing at the cloud node, right? Because once let's say if we send it to the cloud node, the time taken or the latency that is involved may be much more, and then probably the time we get the output at the receiving end So time to act upon may be over. So we do have to process the data as soon as possible. In that particular situation, we say that rather than sending the data to the cloud, we process the data either at the edge node or at the fog node itself, so that the action can be taken at the appropriate time or within the time, right? So that is why we say that fog devices and edge devices will be utilized for those purposes. Not all the applications to be processed at the fog node and the cloud node. Rather, the applications will be processed at the fog and cloud node only when these two important parameters are associated with the application. That is the priority and the time sensitivity of the request, right? So these are the parameters probably which we have taken in consideration for processing the application, for placing the application. The proposed work applies both clustering and classification. Clustering, why we have used clustering and why use classification? Factually, we first did clustering, that is the unsupervised learning, because the data that we do have for this particular purpose are the unlabeled data. And then factually, we using the clustering, we could label the data. So fact, we do have labeled the data using the clustering approach, and thereafter applied the classification, right? Thereafter we applied the classification, that is the supervised learning. So factually, if you look at this particular place, you'll find first we did unsupervised learning, then did supervised learning. Unsupervised learning has generated the labeled data using this clustering method, number one. Number two, it also could give us that what kind of a resources you require. What are the types of resources for the data that we do have obtained from Google Cluster Trace, that I will deliberate. So clustering is used to group the resource pool and label the jobs for the training purpose. That is what I explained to you. Thereafter, we did the classification, and classification is done for the jobs to bring it into the resource pool. And as I told you, we do have made the three categories. We have called it as the fog node, aggregated fog node, and the cloud node. You can differentiate it with edge node, fog node, and the cloud node. Doesn't matter, right? So we did the clustering so that the resource pool also can be grouped, and we do have obtained that three categories are possible. Accordingly, we labeled the jobs in three categories. Labeled the data. Our data is here, the jobs, the number of jobs that are there. So classification is done thereafter. The methodology is demonstrated in terms of efficiency. So the method that we do have proposed, we do observe the efficiency of that method, the timely execution, the accuracy of that particular method, and robustness also. Robustness, how we check the robustness? By introducing the noise. Noise is what? Noise is the disturbing data. So we do have added randomly some noise in the data and tested our model so that how robust the model is. And factually, we performed it with the multiple size batches. Multiple size batches means the number of jobs that we have taken in multiple batches. So factually, we created 3 batches for the experimental purpose also, that I will explain you, right? That will be in the later slides. So the motivation for this particular problem was the job classification is crucial for efficient resource provisioning. So that is why we planned for this. With precise classification, the mapping of task requests with available computing resources results in the optimal provisioning. So we do have tried to provision the resources optimally, right? The placement technique in particular must be light and efficient enough. So the placement technique, that is the controller, that is the admission control manager that we are proposing, this itself should be light enough. Why it should be light enough? Because the controller itself has to run at the fog devices. So as I explained to you in the beginning itself, the fog devices are not very powerful devices. So they cannot process very heavy applications, right? They cannot process the heavy application. That is why we said that the technique that we do have to propose, the technique itself should be light enough, right? And these were the motivation for us to do this particular job or to propose this particular model, right? Some of the highlights of the model is that we do have done the clustering, then standard techniques we applied to cluster the request based on the physical request parameter and QoS attributes that I just explained you. And an intelligent admission controller manager acts on the IoT request in a time critical manner, and thereafter the quick analysis of request parameters, including the time sensitivity and the priority of the request, right? So these are something. So for clustering, what we did, are you able to understand the things? Am I a little faster? Yes, please.
No, sir.
It is okay, sir. It is good.
Are you able to understand?
Sir, I have a query.
Yeah,
Yes,
please.
sir. We understand.
So, sir, similar to cloud native, do we have fog native and edge native applications also?
Yes, there are, as I told you, na, that why for we what for we do have created the fog and the edge computing. So you see that for most of the time sensitive applications, the applications that are not heavy in nature, ultimately you know that the cloud can process, because they house the powerful processor, they house the powerful storage, so they can have any kind of a storage, any type of a processing can be performed there. But then there are certain applications that are very time sensitive applications that do require the quick processing. They are light in nature. Then for these probably we can look for the fog and the edge computing devices, for our fog and the edge devices, right? So there are certain native applications that can be processed at the fog and edge only, but there are certain applications that cannot be processed here. Ultimately for that we do have the cloud. There are some more reasons why we cannot process on the fog and cloud, because ultimately this entire model is pay as you go model, pay per use model. So maybe in order to process the job on the fog and the edge devices, you do have to invest some more money. So sometimes we are happier with little time, you can bear with the time rather than paying more amount, rather than investing more on the processing, more amount on the processing.
Okay, thank you,
Right?
sir.
Okay. So
Right, sir.
proceeding now thereafter, you see that I said that for clustering, we do have applied the k-means clustering, right? So in the first stage, what I said, what we did, we applied clustering. Why we applied clustering? I already explained you that we do have the unlabeled data. The data that we have obtained from the Google cluster trace, they are the unlabeled data. So in order to label the data, we did apply the clustering. And not only that, we applying the clustering, we are able to get an insight of the data, that what kind of a process, what kind of a backend servers it may require, right? And you will see this, you will see very quickly this, that how this based on the data we could guess, or we could decide upon the three types of machines, the three types of processing devices that we do require. For classification, we do have applied the decision tree. So machine learning classifier decision tree is used in this particular work, but thereafter we did apply many more classifiers. Actually, in total, we applied 9 classifiers, so that we can judge what kind of performance other classifiers are giving, right? What kind of performance other classifier performs or other classifier is giving for these kind of applications, right? So besides this decision tree, actually it is not exactly the decision, or the variant of the decision tree we applied, right? And besides the decision tree, we applied the nav based classifier, the linear regression and logistic regression classifier. Deep learning and ANN also has been applied, and I'll show you the result that we could obtain with the application of the deep learning and ANN as well. We did apply the support vector machine, which is very accurate as far as the accuracy is concerned, as SVM is very accurate. So we did apply the SVM and the fast large machine with the SVM. We did apply the random forest also, just like to test how the random forest performs. Though we applied the decision tree, but along with we did apply the random forest also, and we applied the gradient boosting tree as well. So these are some of the other classifiers that we applied for our problem. Ultimately, we propose a hybrid model which applies a combination of clustering followed by the classification. As I told you, as I explained you, the flow model starts with an unlabeled group of requests clustered into 3 groups based on the physical request parameters. Do you have any question? Oh, some noise came in between. The flow model starts with an unlabeled group of requests clustered into 3 groups based on the physical request parameter. This clustering uses the distance parameters. And as I told you, for clustering, we require certain similarity parameters, similarity measures. We have used the distance parameter. after labeling the request into 3 core groups of low, medium, and high categories. As I told you, that we do have, we could cluster the data, we could cluster the incoming jobs into 3. And based on the 3, at the back end, we decided on the 3 types of machines. And at the front end, we could label it in a low, medium, and high categories of the data. The next step is to introduce the QoS parameters. Thereafter, we introduce the QoS parameters to map it onto the 3-layer extended architecture. So that ultimately at the back end, the 3-layer architecture, that is the edge, fog, and the cloud. Again, I'm repeating you that we did call it the fog, aggregated fog, and the cloud architecture. The quality of service data introduced within 3 existing group is based on the domain knowledge of fog integrated cloud. So this QoS data is factually based upon the domain knowledge, right? So ultimately, these are the things which you may require while working upon their own domain. Working in their own domain, you may require. Now the final labeled data with 5 parameters, total 5 parameters, right? We do have discussed about these 5 parameters, and corresponding class labels are available. The labels of the request are according to their associated mapping to one of the classes. For the classification of request, a variant of the decision tree is used. As I told you, for comparative performance analysis, some well-known state-of-art classifiers are used. I already told you, total 9 classifiers we use. 2 possible scenarios for the deployment of the proposed intelligent admission controller has also been discussed. So we'll be coming upon where this controller can be placed. This is the proposed work, and you can just look into this particular model, which will tell you how exactly the model is working. So these are, let's say, the IoT devices that are generating the data, right? These are the IoT devices that are generating the data. For time sensitive data, the nearest fog node processes those data and the action is taken upon. So you see that what I said, the nearest fog node, you can consider it as the edge devices, right? So for time sensitive data, most time sensitive applications, you can say that you can process those data here itself, right? You can process the data as the edge devices itself. We are calling it as the nearest fog node or just fog node. For less time sensitive data, we are sending it to the aggregated fog node. You can call it as the fog node. So if you are calling it as the edge node, this is the fog node. So less time sensitive data, we are sending it to the aggregated fog node, where from the action generated will be communicated to the edge, the IoT devices. And remaining of the data or remaining of the jobs that are less time sensitive are not at all time sensitive in nature. Non-time sensitive data are ultimately sent to the cloud. And not only that, even the data or even those jobs that are for the storage purposes only, they can be sent to the cloud. And exactly this is exactly the model that we are working upon. The work proposes 3 types of computing nodes. As I told you, fog node, aggregated fog node, and cloud node. Fog node, where response time in millisecond, duration of data is transient in nature. Aggregated fog node, where response time and duration of data is short. Additionally, the duration of the geographical proximity is local but wider in the aggregated fog node. And for remaining, we do have the cloud node, where the low priority jobs may be processed. Every time user may not process the application because, as I told you, some money is also involved. Some pricing of the processing is also involved. So not necessarily the user is interested to process the data on the fog and the aggregated fog, and ultimately the cloud is happy with. Now you see that we do have clustered the data using the clustering approach, and we could obtain, with respect to the CPU and the storage requirement, the requirement of the jobs, right? The requirement of the jobs. This is actually based on the Google cluster trace, this particular picture. And if you look upon this particular picture, you can easily make it out what kind of a grouping, what kind of a clustering is there, right? The red one, the red data indicates that they have more CPU requirement and more data storage. So they are more suitable for cloud. Then this blue one suggests the more CPU requirement, middle CPU requirement, and the storage requirement is also somewhere in between. So you see that we labeled it with the blue one, and this is the perfect requirement for the fog node. And then ultimately you have the green one. You can say it is aggregated fog node in our problem, and this is for the fog node in our problem, where the CPU requirement is less and the data storage requirement is also less. So as you know that the fog devices are less capable than the aggregated fog devices, and these are less capable than the cloud devices. The Google cluster trace, which we have, on which we perform the clustering, has given this kind of a picture, and based upon this, we could decide that ultimately at the back end for the processing purpose, three types of architecture, three layered architecture will be more suitable, right? You may find some of the data here and they are moving here and there, that we do have classified as the outliers, and we could remove those outliers also while processing the data. As I told you that we do have made three layered architecture, and then accordingly the jobs or the data has been classified in three clusters. One is the first priority, then is the next priority, and then is the lowest priority, right? The first priority for most time sensitive, less time sensitive application, next priority, and least or the zero time sensitive application have been given as the lowest priority, right? A comparative study on fog, aggregated fog, and cloud node or something like this, that probably is available with the literature. You can go through it and you can very well find it out what kind of these nodes are, these devices are. Then the data that we took, the model used Google Trace for the performance study, and we took the Google Trace that contains the data in GBs of 12,500 nodes for 29 days. So the data that we obtained is for the 29 days data of 12,500 nodes. So the picture that we have just shown on the graph, they are containing the data for 12,500 nodes, right? The trace consists of over 25 million tasks belonging to approximately 930 users. Then for performing the study, we did divide the batches of the job in three batches. The batch one consisting of 300 requests, batch two consisting of 1,000 requests, and batch three consisting of 3,500 requests. Why this? So that we can estimate, ultimately judge that how our model performs, right? How the model performs of different number of requests, different types of different batches of requests. And then if it performs well for 300, but is not able to perform 3,500 batches, the 3,500 requests, then again the model will not be useful. So just to check this, we do have created three batches of the jobs, right? Before we did perform the pre-processing of the data, and the data in the data pre-processing, what we did data aggregation, which is done by combining two primary sources of Google cluster trace. So first we did the data aggregation, then we did data reduction, and in the data reduction we do have removed the outliers, as I told you, and this we have applied the local outlier classifier detection technique to remove the outliers. For data transformation, we use the Z-score. So all these functions factually are available on the MATLAB that you can make use of. Data transformation is done using the Z-score to convert the data into an appropriate form, so that larger or smaller values have no significant impact on the classification. You can say that here the kind of a normalization, the data normalization has been done here, right? That is, we could remove the larger or the smaller values so that the data is compact data that we could obtain. The flow graph of the model is something like this. So all the things that we have discussed have been explained through this flow graph. And this is nothing but first to perform the clustering, then introducing two more QoS parameter in terms of the priority and the time sensitivity. Then we applied the domain knowledge, implemented the classification model in form of the decision tree, and then we tested the model on the accuracy, time, and memory usage. And thereafter we decided upon where the admission controller will be placed. So this is the entire model, entire flow graph of the proposed model. In this particular figure, you can notice it, right? As I told you, k-mean clustering we have used. Thereafter, to train and test the classifier, three batches of the jobs have been created. The cluster one is the green one, which we referred in the figure. You remember the figure? Three clusters we could form. One is the green, another is the blue, third one is the red. Red is for the cloud node, blue is for the aggregated fog node, green is for the fog node, right? This is what we did. For comparative analysis, total 9 classifiers, as I told you, have been evaluated. All these classifiers have acted accordingly on the evaluation parameter, such as noise sensitivity, time consumption, and many more. Decision tree, logistic regression. Now you see that the inference that we have drawn, the result that we could obtain is that the decision tree, logistic regression, and general linear model have fast prediction speed and accurate also with some noise sensitivity. Support vector machine is very accurate in terms of prediction. The graph will also, I'll show you the result of the graph. Support vector machine is very accurate in terms of prediction, but sensitive to noise. Deep learning and ANN predict well, but takes time to learn the input data pattern, right? That is why they could not qualify the deep learning and artificial neural network. As far as other model are concerned, like GBT, SVM, and GBT, they are also good from accuracy perspective, but their interpretability lacks, and they could not qualify even in the runner-up list also for our problem. The evaluation process has been divided into two parts. First part focuses on the result in terms of accuracy and time execution. Second part focuses on the test of significance of the results using the standard statistical performance measures. Right? I'm just coming to the result part. Actually, we introduced the noise also in the percentage of 5%, 10%, and 20%. That is, the 5% data has been corrupted and noise has been introduced, then 10% of the data, 20%. Above that 20%, usually noise won't occur. So we did specified ourselves with the introduction of the 5%, 10%, and 20% of the noise. I'm coming to the result very quickly. The validation has been done. Of course, we did the 5-fold cross validation, but then we were satisfied with the standard deviation. A range of result is obtained with plus minus of change in the actual mean result. So we did perform actually the standard deviation, which gives us the result of 50 runs per data set with level of noise for each batch. So we ultimately were satisfied. We ultimately were satisfied with the 50 runs per data set. Now coming to the result part. So you see that this is the result of the batch 1 data. And this total 9 classifiers in the different colors we have shown here. Total 9 classifiers you will find. This is by introducing the noise of the 5%, 10%, and 20%. So when you have the 5% noise, 0% noise, the accuracy goes up to almost very close to 1, between 0.95 to 1 of all the classifiers, right? When you introduce 5% noise, the accuracy decreases and the different classifiers are performing this way. At 10% noise, it further decreases and the accuracy comes like this. At 20% noise, the accuracy is like this. The proposed model of ours is actually the decision tree, which is shown in blue color. So the performance of the proposed model here lies in blue colors, right? So here you will find that as far as the accuracy is concerned, some other models are performing a little better than the proposed decision tree classifier. But then when you come to the execution time with the different levels of the noise, you will find the performance like this. So execution time, you see that the execution time of the proposed method should be less. And if you just observe this particular figure, you'll find that the execution time of batch 1 job are something like this. And if you look at the blue one, the blue color one, which is the proposed model of the decision tree, right? The performance of the proposed model is the best model. And that is why if you consider the accuracy and the execution time both, the decision tree model performs very well. Execution time is very important as far as this whole architecture is concerned, because ultimately the proposed model has to execute itself somewhere, and most probably the place of the model execution is the fog node. So execution time should be good enough. And as far as the execution time is concerned, decision tree performs very well. Accuracy also, they did perform well, but few other classifiers are a little ahead than those, right? Now for the batch 2 also, the performance is similar. If you look at the batch 2 with the different noisy labels, the performance is almost similar as the batch 1. Here again you will find for the batch 2, the blue color one is taking the lesser time, execution time, right? For the batch 2, the execution time is much lesser when you have the 20% noise, right? Now going with the batch 3, again you will find that the performance is almost same for the batch 3 also. And here you'll see that the batch 3, even for the 5%, 10%, 20%, all and 0% of the noise, the model performs very well. And this was the reason that we concluded the decision tree performs very well. For the validation, we applied, as I told you, we applied the standard deviation as the mechanism. So change of accuracy in standard deviation has been observed like this. And if you look at the performance of the decision tree based classifier, which is the blue one, For batch 1, batch 2, and batch 3, this particular model performs very well for the accuracy as well as for the time execution. So ultimately, the decision tree classifier, we could observe that the decision tree classifier performs very well. As far as the placement of the controller is concerned, we considered two scenarios. One is the software defined networking based controller, another is the fog integrated cloud based controller. And we could suggest that for any of this, at any of this model, any of the scenario, in any of these scenario, the model can be placed very well for the software defined networking and for the, because the software defined networking usually has the three layer: application layer, control layer, and the infrastructure layer. And this particular model, this particular device, in form of this particular admission controller, can be placed at any of these layers, at all of these layers. So this is what we propose. For the fog integrated cloud also, this can be proposed at the fog layer, this can be proposed at the this can be placed at the fog layer, this can be placed at the aggregated fog layer, and so on. So ultimately, this is all. I won't discuss the optimal depth of the tree. And finally, the comparative study of the classifiers on which we tested. You just look at this particular table. Decision tree prediction speed is fast, training time is low, dispersion is inaccuracy is low. And then we concluded that the decision tree for this particular problem performs very well. I suppose that I am well within the time. So thank you very much. And if you have any question, you can, if you have any query, you can put forth. Okay.
Dear participant, please ask question if you have. If you have any query, please ask.
I'm sorry that I'm a little faster because ultimately, in order to explain entire things, this is not a 1 hour, let's say, lecture. Rather, it should be 2 hour lecture. But ultimately, I tried to compress this particular lecture in 1 hour, right? So that probably made me a little faster. If you have any question, please. Otherwise, you can take my email ID and then can write me also. And if you have further queries which arises in your mind.
Participant, you can unmute yourself and ask any query if you have. There is some query in chat box, sir, I think.
Yeah, so
Sir,
I have
why
a
we
query.
use fog
That
when we have
how do
cloud?
Yeah, please. So I have a query, sir. That can you slightly elaborate the implementation process wherein, I mean, basically, how did you use the cloud trace to prepare the data set?
Yeah, actually, see that what we have done here is the resource provisioning from the resource provisioning aspect, right?
Right.
So first, what we did, we obtained the Google cluster trace, right?
Mm-hmm.
That how the jobs are coming there, what kind of a requirement is there, right? So based upon that, we clustered those jobs, and then as this particular job were unlabeled, by the clustering we made them labeled job. That is, we made them low priority, mid priority, and high priority kind of a job, right? That is
Right.
what first we did. At the back end, we do have considered the fog node, aggregated fog node, and the cloud node. Fog node less capable in processing as well as the storage. Aggregated fog node little more than fog node in processing capacity as well as the storage capacity. And then ultimately cloud, which is highest powerful processors, they are housing powerful processor and the storage as well. So based upon that, we decided that how the jobs will be placed upon these devices ultimately. So our job is our model actually predicts that what type of jobs will be coming, and then we can decide upon where they will be placed at the back end, right? So this is the ultimate work that we do have done it. Okay.
Right. Thank you.
Anything else? Some lady was also asking something. They are writing the question, but it disappears quickly.
Okay.
You can ask me. You can just put forth.
Okay, just unmute yourself and ask the question.
Am I audible?
Yes, yes, you
Yeah.
are.
Hello, sir. First of all, thanks for the nice session, sir. My question is, where the fog is located? Is it located, let us say, in the same as a cloud location in terms of
No.
physical?
I already have shown you one picture. I have shown you one picture how we are creating the fog devices. So fog devices are the intermediate devices right? They are basically meant for the communication purposes. But nowadays, these devices are equipped with the powerful processor also. So what has been thought upon that if we can use their unspent time somewhere and can process the application here itself. So these are the switches, these are the bridges, these are the routers, these are the base station devices, and so on. All these devices constitute the fog node. Edge devices we already discussed. Your smartphone itself is the edge device, right? Because this also has the processor. So this generates the data, and some of the data can be processed here itself. So then ultimately, let's say in the vicinity, if you have some of these smartphones, altogether their computing capacity can be explored. This constitute the edge devices. So this is the edge, another is the fog, and then ultimately you know about the cloud. Cloud is dedicated data centers, right? So that we are calling it as the cloud. Okay.
Okay, sir. Thank you, sir.
Sir, this proposed emission control seems to be the deployment of the ML models, 9 ML models which you developed in this study. So something about the deployment of these ML models and how these ML models
See, we
were
proposed
deployed.
decision tree based. We applied only decision tree based classifier, right?
Right, sir.
As we
So,
told you, yeah, the total work we do have divided into two parts. First, we did clustering, then we did classification. So for classification, we use decision tree classifier. But then for testing purposes, that what other models and how the other classifiers will work upon that, we applied total 9. So besides this decision tree, we applied 8 more classifiers so that we can test. And the results we already have shown. Ultimately, we decided upon the decision tree only because the decision tree is light enough, is light as far as this application is concerned, and performs well, right?
Right, sir. But sir,
For this
somewhere,
resource policy. Yeah,
but sir,
yes, please.
somewhere this model must have been deployed. Even
Yeah,
though
exactly.
even though you got the better accuracy with the decision tree model, it's true. Depending upon the type of the data, but somewhere this model might have been deployed also.
Yeah, that is what we said. We said that ultimately, then when this particular model will work upon, we propose two kind of a situation there, right? When our network is software defined, is utilizing the SDN network, then where it will be placed, and then ultimately when we are talking about the fog integrated cloud altogether, where it will be placed. And these two deployment models we do have discussed. I just explained you though very quickly. The reason being the time only, right? And factually, if you are more interested, probably I can send you the paper. You can look into the paper, and then we can deliberate, right? Thereafter, factually, as far as the deployment is concerned, we propose two situations in which this particular model can be deployed, right? One is the SDN based networking, another is the kind of a dedicated fog integrated cloud network. Okay.
Right, sir. Thank you so very much.
Okay, now I request Dr. Nayan Bhosle sir to propose vote of thanks of Dr. D.P. Vidyarthi sir. Please, Nayan sir, over to you.
Thank you, Pawan sir. I would like to thanks our expert speaker, Professor D.P. Vidyarthi sir, for making an excellent presentation and making this workshop very meaningful and interesting. Our participant getting insights to making start the smart applications with the help of IoT. You have given a depth insightfulness on the cloud, fog, and edge computing with similarities and differences. Like cloud computing, not closer to the user, and fog computing is very close to the data generating. I think so. So along with many minor and major points have been covered thoroughly to justify the means of this workshop. I'm sure all participants of workshop may get benefit from it. So because of COVID, we are running this workshop in virtual mode, sir. So we are in near future. We'll invite you again. So please do visit our campus in person and have a Narmada Darshan at holy place of
Yeah,
Amarkantak.
sure. That will be my pleasure.
Already Yeah, already Professor Vijay sir and Raza sir visited our campus means before the COVID only.
Yeah.
So on behalf of the entire team of IJNTU and Department of Computer Science, I would like to thanks to you, sir, for accepting our invitation and delivering a beautiful session. So
Yeah.
thank you, Professor Saab. And
It was my pleasure delivering a lecture at your particular place. Many of our students had been at your place, Ram Shingar Rao and sometimes Sanjay Das also. No, he was there.
Yes, sir.
Actually.
Yes, sir.
yes, he is our
So
colleague, sir.
they were our student here in JNU. They did their PhD here, right? So
Yeah,
they were
Yes,
already
Rao sir
there.
is my guide, sir.
Anyway, thanks a lot for inviting me to deliver this particular lecture. Thanks all the participants for their patience hearing that they could hear me for a long 1 hour and 10 minutes. So thank you all the participants. Thank you the organization. Thank you very much.
Thank you very much, sir,
Thank you,
for giving
Professor
your
Saab.
valuable time, sir.
Okay. Okay. Thank you. Namaskar.
And Rao sir is my supervisor in PhD.
Ram Shingar Rao.
Yeah. Yes, sir.
Oh, that's good. That's good. That's good.
That is a chain we connected.
He had been student, my student here.
Yeah, yes, sir.
Okay. Yeah.
Thank you so much for giving your valuable time, sir. And
Yeah.
please share your PPT, sir, on my email ID, sir.
Okay, I'll do that. I'll do that.
And I have sent a mail to you. It's a receipt, honorarium receipt. Please fill it and send to me, sir.
That I'll do. That I'll do.
Thank you, sir. Thank you so much, sir. Thank you. Okay, participant, it's a 1 hour break. We will meet at 1:30. It's a lunch now. So we will meet at 1:30. Okay.
Thank you, sir. Thank you, sir.
We will meet at 1:30, sir. So
Thank you, sir.
5 minutes before. Thank you. And fill the attendance. Okay. And you have to fill you have to fill the daily feedback form. Also, it's mandatory. Okay, a lot of students are not filling the form and not joining the session. Okay, they will not be received the certificates. Okay.
Yes, sir.
Okay, so you have to fill the attendance daily, twicely in morning and evening session, and at evening you have to fill the feedback form. I will send the feedback form daily at 3:30 p.m. Okay, and you have to fill the feedback form till 10 o'clock night. Okay, of that particular day. If you have any query, you can ask to me.
Yes, sir, please. I do have a query.
Yeah.
I started filling feedback form. It was for yesterday. Timings were 10 o'clock. In fact, in the morning yesterday, it was inaugural session. Right?
Okay, actually there was lot of queries, okay, regarding the feedback form. I have opened the feedback form for half an hour only so that they can fill for the previous date, but now it is closed now.
सर एक्चुअली मेरी क्वेरी भी पूरी नहीं हुई सर. अभी क्या होता है ना कि जब हम लेक्चर अटेंड करते हैं तो स्पीकर कौन है, क्या टॉपिक है, उससे ज्यादा हम उसके कंटेंट पे कंसंट्रेट करते हैं, है ना. और यदि आपका वो डिटेल प्रोग्राम
लिसन मैडम, स्पीकर का नेम वो सब शेड्यूल में है, मैंने शेड्यूल कई बार शेयर किया है.
मैं वही कह रही हूँ सर, एक बार आज भेज दीजिए क्योंकि मैंने अभी भी टेलीग्राम ग्रुप ज्वाइन किया. मैं यही कहना चाह रही थी.
ओके मैडम. ओके,
मैंने होटा सर खानी पे एचओटी लिख कहीं नोट कर लिया था, दिमाग में भी था कि ऐसा लेक्चर दे रहे हैं ऐसे.
It's a responsibility of the participant that they have to note the speaker name also. Okay, what they are telling to you, they are delivering to you. It's responsibilities.
जैसे टाइटल की बात ही है ना, तो आई एम अवेयर दैट ही some speaker is talking about supervised learning or unsupervised learning, but what the exact topic is, generally we miss this.
Okay. You have to join the session at starting. Na? They generally flash the screen. Don't worry. I am sending the morning or evening session screenshot on the Telegram also, so that you can fill from there. Okay.
At least name. Yes.
Okay. I am sending on a Telegram link, please. Okay. Thank you. I am ending the meeting. We will meet at 1:25. Okay.
1:25. Fine. That's great.
Thank you. Okay.